Yes. Same settings. We should be live. We are live. Yeah, with my phone, but oh yeah, with this camera also. Okay, I'll try it. Yes, we are live.
It's already live?
Yes, we are live. It's a rolling scrolling.
No, I'm taking something.
Testing, testing.
Young people. We are going to do vision continue from yesterday. So I would like to know, like, do you face any difficulty? Yesterday night we tried to
You can fold the legs on the legs. Fold the legs.
Oh, oh. I thought I need to.
what? Okay. Species. Then after that, you capture the image stream from your this data is what so for today, the vision, but showing something more present. Right? So instead of just capture the image from your camera stream, we can take the data from the camera and do some processing. What we see, and what is for example, like a human that appear in front of the robots, and then the robots can detect that person. That's the objective for today. Today. Then not just the face, but later on I will show you some more color. For example, you detect some colors. You can detect some object, you can detect some facial expression, even your gesture. So these are the things that I will show you. But kind of quite more different type of format of topics, so that you can get a lot of results from different accounts. So those are the things that I'm going to do. So I hope I can finish the vision part maybe in the first 1 hour. Then we can start the navigation. So we are going to prepare to give you like more view, but in competition or in real life it's actually more complex. But just to show you the concept, we have about 2 rooms. So you can see we have 2 entrances, one exit, one entrance, and then there is a partition in the between to see there are actually two rooms. So from this environment, then you will, so today you are going to upgrade your hardware. Okay, so you are going to put the iHome on top of one of this the platform. Right, so with the three going on your kitchen. You just put the iPhone on top, put the laptop on top. And then you can use this as your mobile platform to move the robot around. Okay, then we will learn how to move around, use the map, and then you're going to use the map and use the localized to make the robot able to move from point A to point B. Avoiding while the thing chemical. I show you one time dynamically someone that in what allows
Remember,下面有人。
maybe solution. Okay, so that is one
Yeah, definitely.
Yeah. Hi. You how do I create a complete service robot? Like for example, you want to make a robot for delivery house. So the robot needs to be able to move from one point to another point, need to be able to interact with the guest, for example. Okay, so that's one example. For example, you want to build a robot for reception houses. So how the robot able to, for example, recognize the guest and recognize guests who haven't registered, etc. Right. And then or you want to build a robot for example, like hospital, for shops and so on. So those are the roles that we will test in the competition by designing certain particular tasks. So how you want to incorporate all the things that you learn in this module into one service robot application. So I will talk a little bit more from 3 p.m. this afternoon, and hopefully we can settle everything before 5 p.m. Right? Okay, so that is the overview from today. So now, I hope you already like put up your PC with the iPhone. So let's continue with right. So when it comes to freelancing, I think like it's already done. So by now you should be able to take photo and should be able to connect with your speech. So the next one is this OpenTV application. Okay, but we want to show you the data, right? I want to show you the outreach. So can the data stream like point on one of the PC? Anyone do it? Can you use this? Can you see the So for example, like before we start this, I'm going to show you the data stream, right? So first. Yeah, maybe you want to do this very. So here, tools called Today, when we run the Ultra launch, we have the image from here and also the text image, right? black color one, right? Remember that? Okay, so now if I plot this data in 3D space, how it looks like. So first I show you the image here. Yeah, this one, right? Okay, so this one is this information. Okay. If I put this to 3D space, for example, like I do this. So this one, so sorry, maybe you need to see something. Or maybe I pointed like this. Yeah. Yeah, somewhat. All right. So this how to pen? I need a mouse. Okay. Right. So you can see this the figure, the body, this is front, and then the color actually shows the depth. So yesterday, remember the black color, that image, the depth image? So if you put in 3D, this is how it looks like. Okay. Right. So this one, you assume this is the okay, because it's supposed to fit on top of the box. Okay, so we can see this. So this one is the depth data. So now, if we combine the depth data with the color information, what will happen? So within each pixel, for example, like the light red reach here, bounce back. So this one got the XYZ. We got a lot of XYZ, right? So on the XYZ, we put the RGB. So we have the RGB and XYZ synchronized. And we can see the data here. So can you imagine? Can you imagine? Right. So you have the XYZ in between space plus the RGB. So this kind of data you can actually get from this. So from this kind of data, we can do a lot of analysis. So not only in the image, but the geometry of it. So from the geometry of the you can do a lot to make the robot understand the things happening in front. Okay, whether you want to detect the face, you want to detect movement, you want to detect object, you want to detect, and even you want to know the distance, you can make this, hold the arm, you detect something. So that is why this RGB sensor is very big. Okay, so now we can visualize it. See the little dot. Outside. Okay. So this is what I want to show you. So now we are going to a little bit more. We use this information and things happen in the robot environment. Okay? Alright, that's what we did. Okay, you can talk about that. It's good by the code. Okay, so for without changing or without developing open and code, you can actually type and use the upload line.
Just make that smooth.
Oh.
Okay, so image processing.
Check it.
Once we put the data from the code, you can do a lot of processing. In the processing, we can do a lot of algorithm, we apply of algorithm. So those are the things that you learn in image processing. So that's subject. I don't know whether it's in the course or not, but yeah, those are the things that we do in image. So for example, applications, rejection, okay, so you can try to relate what you learn in class and try to apply to what you do. Okay, so for that, if it happens to be, I just want to show you one. Okay, so maybe I need to go back to I need to go into the OpenCV the links. I need to go back. This one. So I want to show you this. So it's OpenCV that I'm going to show you that we're using, and this package is very useful, I think, because it helps us to very quickly develop or use OpenCV function in Rust. Okay, so over here, so you can see that the package needs quite a lot of these features that available. But due to the time constraint in this workshop, I can only show you a few which is relevant to your task. But if you do a lot more image processing stuff and you want to explore more for your different kind of application, yeah, you can check this. Because for example, like some are quite, for example, this motion analysis looks nice. If you want to do like object tracking, so on. Maybe I will show you this face detection and people detection, right? So we have face detection, recognition, and people detection. So this is these are the examples that I will show you. Some other things, for example, edge detection, I will last line and all these things. So maybe you want to do like some advanced stuff, for example, set some features. You can do it, and it's already available in Rust. Okay. Other thing, for example, object segmentation, that's quite a lot. Right. Image filtering and so on. So these are features or functions that are available in this open set that you can further explore. So why I want to show you this is so you can available. Jump to one of my examples, which is the first example I show you is color tracking. Okay, so color tracking is very fundamental thing, right? Handshake. I'm not going to explain the algorithm calculation here. Okay, so you pick myself. You just need to go back to get on the link from there, and also you can search Handshake, OpenCV, and get the documentation from OpenCV. Okay, so but what I'm going to show you here is how to use it. Right, so Handshake is some very I'll say very basic image processing example that show you how we can use some technique, because we know it is actually a bit array of RGB value, right? So from there we know the color represented by numbers, and we can apply mathematical algorithm to actually find certain color, for example, and then we can find like what is a big patch or one big area having a single color. So that is something that you can track a particular object. Okay. So in order to do this, first you bring up your camera. So whether you're using a USB cam or you're using the Astra, the IO using the Astra, so you can use it. Again, the slide we need to update with Astra camera, because this is, I think this set of slides is a bit old. So the old system is using Astra launch package, but now they already update to Astra camera package. Okay, so change this to Astra camera, and then we are going to use this topic, which is the RGB. So this example only use color information, right? RGB image raw, and to launch the node. So after you have bring up and you identify this is the image that is already available, you can use raw topic list to check. Then you can use the raw launch OpenCV app. So this is the package. And then this is camshift.launch. This is the node name or the launch, sorry, the launch file. And you can see behind there's actually another this is what we call the argument. Okay, we need this argument to be input into this camshift launch, because this argument is important to tell this camshift example which topic of data to use. Okay, because this camshift example is universal, so it can accept any image topic from any kind of channel. Okay, so over here we are using this. Okay, this one. So you can type it. And if you are using the USB cam, if you are using, for example, a normal USB cam, then behind here you should replace it. Right? Remember that, because after this workshop you might using different sensors, different color camera, and so on. And depends on the driver, the image topic might be different. Okay, so you need to know like where to find the image topic and how to fit in the image topic for that. Right, so this is how you connect the image topic into the camshift account. Okay, so can someone run this so that I can show you the example?
OpenCV apps for functional timing.
No, you don't freeze frame. So, can I have example like that? Okay, right. So, yeah, if you want to see an example, I'll show an example to here. Okay, cool. Okay. So, okay, this way is one version. This is green color, for example. Okay, so can you like draw a small square over here? Okay. Right. So can you see? Right. So you can use the mouse to select a small sample. Okay. You use the mouse to select a small sample, and then this sample it will calculate from this sample. Try to find it. Okay. So you see this region have the same similar color, and from there you can track. So this is how it tracks. Right, and you can see up there, there is actually a Vmin, Vmin, Vmax, and also Smin. So this one is in HSV space. You know HSV? Hue, saturation and value, right? Why it's using HSV is because like it is more less dependent on the illumination, the light illumination, or the intensity of the illumination, which means if we, for example, like if we use RGB, we turn on and turn off the ceiling light, the RGB value change a lot, right? If you done this RGB, but for HSV, the value of HSV actually change. The difference is less because it's only, I think, if I'm not mistaken, the HSV, I think that it's the V value that change, but if I'm not mistaken. So you can use the V, Vmax, and S to adjust the sensitivity and also how variance the, for example, like this green and this green, are they the same? Okay, you can adjust that. But for this example, is I think it's using the HSV color space. Is because that color scheme. That I think that is because like it is less dependence on the light intensity. Okay, because color is very easily to be disturbed by the lights, shadow, and all those things. Okay, so that is why it's designed. But this example is a very color-based algorithm. So if you have very noisy environment, it's not going to. Okay, but this one is just to show you one simple concept. How to track certain things. But of course, like a lot of my students, they use this in a lot of ways. For example, use this to detect object, to track object or certain things. Okay? Okay, right. So this is one thing, but haven't finished. Can you open up one new terminal? Okay, ROS topic list. Okay, so can you like open up a bit bigger? Yeah. So you can see after we run the cam shift, so we want to see, yeah, you can see there is a set of cam shift topic being generated, right? And inside here, some topic can give you very important information. Okay. So can you see that from here, cam shift over here to this one? Can anyone like give me a wild guess which topic actually will give us the center of this tracking? Try to give me a guess. Can you type box? Try box, okay. Can you like smaller this a bit and put the just now the image at the side? Make it smaller. Yeah. Drag this thing here. I think lost. No. Right. Okay, so I need something like this. Right, so can you type ROS topic echo? ROS topic space echo slash cam shift and slash echo and then the track box. Yeah, just type according to, okay. Yeah, track, yeah. Okay, enter. So can you see the XY? Can you see like I move here? Can you see the change of the XY? Right. So now, without changing any or without writing any OpenCV code, you just subscribe to this topic, you already can see the XY. And with the XY, what you can do? You can do a lot of things. For example, like, can you move the object to the center? Then from there, okay, you see the XY, then see, okay, to the left, to the right. So basically, this is actually the first example I want to give you. But instead, because yesterday, because of some discussion, I'm going to change this to the face detection actually. For example, because you don't have much time to do exercise. So I'm going to give you another exercise that use the face instead of this. Okay, but it is actually the same idea. So now you understand like why public subject is so important is because this example taken somewhere, right? So I just need to analyze what topic it has. I subscribe to the topic, which is you already learned how to do it yesterday, and you already have the XY. And with the XY, you can do a lot of things. So you already done your color tracking example. You got what I mean? So you know how to use this, right? Okay, so I'm going to show you another example, and then only we start to do that. Okay. One topic. You can explore other topics and see what other information will be useful for you. And you can see, you do all this thing, you no need to write even a single line of OpenCV code. Okay, it's a very shortcut, but that is the beauty that once you learn this, you can actually use a lot of other people's function that is already developed and then you can do that. But of course, if you want to, for example, like do some extra, for example, fine printing or schematic, then maybe you need to open up the original source code to do some modification. But the beauty of all this material is these are all open source. So you can even find the same. So that's the benefit. All right, you can go back to the GitHub just now. You can get this original source. Okay, if you want to go advanced. But before you go to the advanced step, I want you to learn how to use the available information and do some application development. Okay? All right, so this is one example. Can you try this example first before I explain you the other advice?
So then how XYZ, like the 3D diagram.
Okay, this one is only RGB. Yeah, there is no XY tag. Later I'll show you the XY tag. Oh yeah, so press on both. You can send the histogram is basically show what color you have chosen. So you want to try to choose the color which is not too many colors you have chosen. If you choose too many colors, then the whole thing will also be like you select right, so this one is G what application you have built on. It's said that it doesn't get all of the sample is like my sample is okay. It's already good. So you select more area. You only get one sample in one. Okay. But maybe you do it actually trade here. Maybe the one or the green one. Try different. Something like this color and you need to be a pattern. So that's the small pattern you try to connect one program. For example, like this color, this color. Yeah. This something like reference. Yeah, you get that. Depends, but for this one, you go to track online. The bigger area. One will be Okay, proceed with another example. Yeah, so I need to proceed, right? Okay, so now let's try. So over here, so first you similarly you start from your radar. Again, reminder abstract not terrible. The topic is the same. Camera RGB image log, so you use the RGB information. Then, first you try the face detection. So over here, the difference between face detection and face recognition is face detection is the first step. You use algorithm so that the machine from one frame of data, it try to find out or extract any of the area in the frame belongs to a human being. Okay, it doesn't matter who is that face. Okay, it doesn't matter. But you try to see if there is any face inside the frame. Okay, and for this algorithm, it can detect multiple faces. Okay, it can detect more than one. Right. Then I have another example which is called face recognition. The face recognition is built on top of face detection. Okay, the second step. So once it detects the face, then it will do the second test to check if the face is something that you have trained before. So before you can run the face recognition, you need to do the learning phase, which is you need to teach the system or certain face information. So you need to do like take the face and then say this face is Alex, Peter is whatever. Okay, and then you take a few more so that you got a pattern matching like example. Right. Then after you have trained the system, like this face belongs to some name, of course you need to train more than one, okay? Don't try one, try more than one. Like maybe you have 3 person in your team, try to train 3 faces. Then after that you restart the face recognition, you can see once it can detect a face, it will try to calculate the similarity of this face to the one in the database to see how confident it says this is Alex or this is Peter and so on. But the number there can be not very high, which means it says it might be Alex but not so sure. Alright? And because this one is very like simple pattern matching way of like face recognition, so the accuracy might be not that high. But it's good as an application purpose to let you understand how face recognition. Right? So I want you to test the face detection first. Then I will show you the face recognition. Then for the people detection is sometimes you want to just find how many people in the room, for example. Okay, and then a lot of times it's like when your camera is too far, you can't even see the face, or maybe like sideways or behind. Right. During that time, this people detection is not using the face, but using the body to track if this is one person, another person, and so on. So you can use the people detection to track how many people in the frame. Okay, right. So let's start from the first example, face detection. Right. So can you try with face detection? Yeah, you can try more faces. Okay. Okay, and over here maybe I need to so it's easier. This algorithm more than 20 years. Okay, very well. But it is very robust. So that's why I think today we still use it for education purposes. But today we have a lot more improved and sophisticated face detection, which is more accurate. But this one is good enough. You can see it's good enough. But the one of the weakness is you are looking to the front. It's quite different. Because this one is using the classifier of frontal face. If you check the documentation, you can actually use it to detect your eyes, your mouth, and so on. Okay, so once you run the face detection, I want you to check the topic, which topic is useful. Okay, what will be useful for you? Even if you do two phases, in swing and give you more. Oh, that's what. Yeah, okay. And even if you go here, you can do the eyes. Okay, so now, here comes the first exercise. All right, here comes the first exercise. Please try to write an application that instructs the person in front to position the face in the middle of the frame. Right. Listen here. So this is the exercise. So try to combine this face example with the sound example, like the TPS example that you learned yesterday. So try to use these two examples. Combine them with the XY value that you can get. You try to give the instruction to the person in front of the camera so that it will move its face to the center of the camera. Okay? Center maybe is not just left, right, also up and down. So that it is exactly at the center. Then, once it is at the center, you get your. Okay. Good. Please example, the max I can do is 1 hour later. But I hope we can settle in 30 minutes. Okay, that's fine. Chắc chắn là giáo dục đâu mà okay, you can try to estimate sample value and use that. Okay, if any of you don't understand the question, raise up your hand on screen here. You don't understand the question? So that you do a check and then you check the sample value. And then if the sample values, okay, you can use one from the page. You try to find the value from the right. So if price is not sample regions, you can to the left zero or to what and if the face need you can okay now face it out beauty has that one that is there which they has to make it you want to go on question listen. 会把那个不管国际法第三个，我有听说过万金三个字。说现在的这个没有非常的嘛，都是直接找到老板，我给你关过来。因为从这个来说，有一组的讨论，你非常被你也是那种方便，很好。你这个也，如果到时候你不敢轻一点的说，对吧？如果说按照我们大的观点，我们想法，人也太快，都把不干更简单说，因为我要求就是看这边发的也可以讲，我至少我放在那里两百多万，这个是没有办法。对吧？所以像这个，因为不管咱搞不了，啊，最可怕的是这样，也就是。You understand, right? Okay, so one very important piece is when you subscribe this topic, it is no longer string. Okay, so the challenge is how to subscribe some format that is not string. Okay, so you need to know. Okay, so that is challenge. That is something that I never mentioned yesterday. I think you need to figure out. So yesterday, I think today, if you look carefully the example given, if you still remember, every time when you subscribe form sum.msg import something string, right? So you need to change that. So it's no longer string. And how to check what is the format of that topic, I already show you in the class, right? You need to define the type. And you need to analyze the basis topic. It is actually a structure. Data structure. So how you want to extract just the XY, because got a lot of value, right? Header and stuff. So how you going to get the XY? The hints is data. Remember? So from there, okay, I already give you enough tips. So from the hints, we're going to figure out how to do it. Okay, so it's no longer string, okay? It's not string anymore. When you construct that topic, you need to check which xy you want to take. Is it the first xy or second xy and so on, which is in the gray? So you to look carefully on the data. Really done. Almost. Okay. Very good. It's not wrong. Recommend don't do that. So stop. You just use and this. You give the information, then you take photo. Don't change from there. Write another user because if you change from the photos, you will get confused. Yeah. Our CEO will use underscore. It's like the not be look at the color. And you need to be careful you have this. So sometimes you only read the first 2 days or you want to like do it for all that. But your application is only like the first page, right? So you only want to have the data. And because So we have now three components, right? So yesterday you learned about the DDS. So DDS is a node to help you to read out any text event, right? So this topic, okay, depends on what topic you put up, right? So it subscribes to a topic, and whatever topic, for example, you put hello world, then you read out hello world, right? Correct? So this is what the component that you learned yesterday. Then you have the take photo stuff, remember? Right, take photo stuff. So take photo stuff, right? You subscribe to the take photo topic so that every time you can work. Of course, take photo stuff also depends on so these are the two things that you need with, right? Now, it's a face detection. Face detection actually come up with a lot of topic. Okay, this is public. And you know like there is the faces topic that give you the X1. Right. Okay. So now what you need to do, the best approach is you write a new node. A new node. Okay? And this new node, maybe you can say like photographer node or something, right? Okay, so first you need to subscribe to these spaces. Why you need the X1? Right now. But this subscription is different from all this is because the data type of this is not string anymore. Okay? And how to check what is the type of the topic, refer back to my slide yesterday. Okay? Then you need to change. To subscribe, you look back your listener. Up there you need to like from whatever you need to import the appropriate data type. Down there, when you subscribe, you need to specify what is the type. Okay, and then your callback because it's a subscribe. So when you call back, how you want to get the XY? So something dot something dot. Okay, like yesterday you had the data dot data, remember? What is the structure? Alright. So once you can get the XY, then you try to find the center XY as a reference and compare the value. If the value is not in the center, then you take to the left, to the right, go up and down. And how? This one go to DDS. How to go to DDS? Publish to this. And do this, you will take DDS. Okay. Then, when you want to take a photo, publish. So this is the answer. And you're supposed to write this. This is the architecture. Okay. You cannot print it. And this is not how the way you can do freehand. Don't do freehand. Not in hole and all those things. Okay, but how freehand would play? How do you use the loss mode?
Yeah. 所以那个导是的，我的这个。So first phase, because when looking at phases, you will have phase one, phase two, ID. Yes. So you need to know how the data, check the data, check the message pattern, the message, how the message got MSG look like.
Because the message format. So first on the topic, then you know, okay, and also you know from which academy. Okay, then you can tell us. But this is very similar to the one that the output丢出来，拿到这个电话，然后才加一个把那被缩了，然后才一个步来快，做到。 Faces, right? That's how we want to check. Challenge today of today is yesterday you're dealing with this is not the swing back. Right? It is defined in not the standard method MS. Right, so that is one of the big difference of values. So the first thing you need to do is when you start writing a new code, the first thing you need to do try to subtract the list and get the xy value in 1. This is the first thing you need to focus and forget about test. You don't need to think about it. Do this first. Do this. So there are 2 places that you need to be careful. First, how to import the message type. So you refer to yesterday from standard message.msg import string, right? Same format, but this time you are importing from a different message, MSG, and a different message type. Alright, the answer is open cd underscore x.msg, import the face array, span array something. You can check from the topic type. Okay, so that is the first place that you need to change. Okay? Now, when you want to subscribe, you write the subscriber, then what is the topic? So you need to put in the topic name, which is face detection faces, right? right? Then you need to put in the same message type that you already got. Okay? The type of the topic. Right. This still fine. But the next challenge is you need to fit the message in the topic into a callback, right? So you put a callback and then you got the data. Okay, so the next thing is you need to look at the one that you echo, or you can check the message format. You got the header, remember, and other thing, rectangle, and blah blah blah. Right? So you need to check which one to find, to choose, and then something dot x, something dot then y. Remember? You know that. And then also you can see from the message type of data type, faces is an array. Alright? Because why it is an array? Because of when you run the program, the possibility for it to detect more than one faces is there. Which means the program can detect more than one faces. So when two faces got detected, you can actually see from the echo, you got face ID number 1, face ID number 2, and then what is the X for number 1 and what is the X for number 2, right? So you need to also specify which line in the array to pick up. And if your application only cater for one person, then only you need the first one. Forget about the second one. But you need to indicate which one to take. Understand? So you need to like something bracket 0 or bracket 1 or something, then dot something, then dot x. I will give you all the answers, okay? You just need to figure out those things. Then you got the next one. Then you compare with the center value and then you give the instruction. Like whether you want this one to go to left or right, you just send the message. Once it is in the middle, you send to take the photo. Okay, to this point you have what you're doing is to be because we are going to move to another example. So now I want you to remember what I said here because you can continue this after the right? Don't write the code anymore because we are going to proceed to another example. But up to this point, I want you to at least understand this solution. Okay, so don't try to change TTS or this one or this one. You don't need to change on any of this code. You can use it technically. Okay, this is the philosophy of the design of raw system previously. You will use all these things and write a new one to assemble them together to create the application you want. That is the way how we do it. You got it? Okay, at this point, this one did. Okay, because I don't want you to continue writing code. We are going to move to the other. Yes. No way we can do any of the like. What do you mean by this one? What do you mean? This one? When you subscribe to the topic, so the topic name of course has to be the same. You need to specify on which topic. So the topic will be followed back to this topic. Yes, of course. This one you can create a new package and create a script. Or the potential or the one. Or the okay, this one.
This defined by ourselves for the
next one is provision. You don't change any of this, you just subscribe and use the value. Use the result of this.
so data.
These are generated by this. Okay, so this is already fixed. You don't need to change anything. You just subscribe. You use the data. You use the data and you do something. So this part is where it will be created. So you create this part and you assemble them together. Okay, up to this point, is there any more question? Make sure you understand this one about the detail first. You can figure out the detail later. But this is a very important concept. So if in your mind, if you are still not clear, ask me first. This is something that you need to go over. Got it? Okay.
Very good. Sorry. So, yesterday I said the philosophy of ROS or whatever we create is we try to reduce whatever that is given, don't try to change them. This is the example. This one, face detection, I show you. Once you run the face detection, it gives you a lot of topic, and the topic that is useful for you is this one, faces. It's something like face detection / faces, right? Okay, so when you echo this, you found like it actually gives you the XY of the face detection. So that is the value you want to use in your application. Okay, good. Then you also want your application to say something like left, right, to the left, to the right. You are in the center, stay still, I'm going to take photo, 1, 2, 3 sheets. You want to say all the things, right? Okay, yesterday we have the TTS, which is whatever message that you send to this topic, it's going to read out. Okay, so this one also you can use. You don't need to change anything, just use it. And you already have the topic, what is this topic? Input, right? Yes, so you just publish to this input topic, you will read out. But this one also. Then we have remember? So take photo stuff to a topic called take photo / take underscore photo, right? So every time when you send a message into this topic, it will capture the image. Right. This one also you can use. You don't need to change anything, just run the node and it's ready. So now what you need to do is you need to write a new node. You can create your own package. You can put in whatever node name you like. It doesn't matter. As long as all of this is in the same workspace, it will work. It will link to each other. Right? Okay. So now you create a new package. You create a new Python. Okay. So you have a Python code. So if you want me to tell you the steps, this is the first step. This is the second step. This is the third step. Okay. So first step, write a subscriber because this is a subscriber, right? Write a subscriber to get the XY value. How to write a subscriber? Go back to yesterday, the listener. Okay, but what you need to change, as I explained just now, the data type, the message type of this topic is not string. Because the listener, you are subscribed to a string. It's simple. Standard message.msg import string. That's okay. But this one is not string. So how to check? First, I already showed you yesterday how to check the type of the topic. If you forget, you can refer back to the type. I think in the raw data. Okay? So after you check this one, you figure out, okay, it is from the open_cdf.msg message format. Inside there, we got something called phrase stem array. Is that correct? Phrase array stem format, yeah. So that is the message formatted type. Right? So you need to first, when you subscribe this, you import the correct message format. Right? Not string anymore, the phrase array stem. Okay? Then now that you write a subscriber, you indicate the topic. Remember, raw py subscriber bracket first argument topic name. Sorry, yes, topic name. Right, so this topic name. Right, you write the full thing, okay, full thing to one. Then the next one is the type, which is the phrase array stem, right? Okay, then after that, the last one is callback. So you already subscribed. This message will flow into the callback. So in the callback, yesterday when you want to use the data, you put data.data, right? Yeah, because if you look at the structure, it's data semicolon value. So it's data.value. But today you want to do something like extender, there's something then phaser, there's a bracket. Square bracket indicate the range, then something else. So maybe it's something like phaser, I can't remember exactly what it's acting. But you need to look at the structure, you read from the word, and then what is the array, whether it's the then dot. That will give you the value of x. So do this thing until you get the x and y. You don't need to publish anything, you just use the log info to print out to check if you get the X or Y. You just run your program and then you move your head. If the XY correspond to your movement. If yes, then you successfully get the XY. Right? So once you get the XY, okay, you have to this part settled. Right? This part settled. So then you look back to your frame, you try to indicate what is the middle point of the frame. What is the X value and Y value of the middle point? Maybe you can get a region because one point is very hard. It's very hard for you to position to fall. So maybe you can find like if your X is within this region, you are in the center. So find this range and then you compare with the XY value, the X value. Okay? Alright, so if it is different from it is outside from this region, then okay, so next you add a publisher to this topic. When this topic is input, you add a publisher, you know how to write, right? You write publisher inside here, you publish to this topic. Left, right. So when you are got different, you can still move to the left or move to the right. Repeat this until the face is in the middle. You write under partition, set the technical way. It's done. Anything? Okay. So let's move on. You already know how to do. But at least now you know the concept of the lecture. The rest is you need to take like the syntax and all the details. The syntax and everything we need time because we don't have the time to practice. So I hope we can do the practice after. Right. Okay. So now the phrase recognition, but you do some learning first. When you run the phrase recognition, it will say like it's a main. Then you try to position your face in front, and then you take a few photos. Then you restart the program again, get another person to train, and then after you train like 3 persons, then you restart the program again. Then you can see when you are in the frame, it starts to like give you the bounding box and give you the name that you label, and also one number, which is indicate the confidence level. Okay? And then, once you have it done, you try to print the topic again. And this time, in your, just now the structure, this one, it actually gives you not only your XY, but also the label, which is your name. So with this, you can include the program just now, like say, Alex, please move to the left. Or Peter, please move to the right. Ignore the name. So you can even subtract not just the XY, but also the name. Okay. Right. So try very quickly is try this face recognition to make sure that you're familiar with how to recognize the face, then you are doing it well. Is that okay? So please try face recognition. Try to train your member to see if you can recognize it. Yes. What do we know? Can you know? Do not check anything. This time, the way the last one can do that. Right? Yeah, actually, one. Try to continue. It's trying to bring engagement. And the details that try to train them
face properly. If the photo just a few, at least 5 minutes. Another person reach out to press while the person is doing. Take a few really fast, right? Try to train a few person, not one, and two or
Can you take only one face at a time or maybe?
no, can be more. But make sure you train a few person first.
We did, but
You train a few person first, then only you.
yeah.
You will try to match the face. So even though you haven't trained before, you will try to match you with someone from the database. But that varying will give you some indication whether the detection is still. They will try to check on the time people do it. See, native gear the table. So you can still construct. In the home directory, you show the hidden file and inside the network maybe and also the folder of then you got a spread entry, that's what you look at it. So you need to put again a look at it, go wrong. Yeah, something that one is in a way, how you so you specify square bracket of 0, not not true. First phase, then we right, it's working, but you need to have a good, like amount of data, right? You train to big amount. Because one big point is that if the person never trained before, the system will forcefully detect someone. But maybe the number is too low. So we have to find a threshold to say that whether this detection is correct or not. But the threshold is not easy to select actually. Because well, the detection is not very reliable. Okay. But just for education purpose, you know like this is how this works. Okay, right. So this one is already done, which is good. But I want to show you something which is not inside here. Because after this, yeah, it's already this information, but I want to show you something because it's one. Yes. Right, then something extra. This is something extra. So I'm going to show you like example to do even deep learning stuff. So you can try on this Lolo. So you do the abstract camera loss. You can try this Lolo open post. And this one is not really related, but this tree, I want you to try this tree, and then you also check the topic to see what are the interesting topic that you maybe you can use for your application development.
right? So maybe you want to try this, and this is something that, but this one is not easy to set up. For example, just on the OpenTV, you just pull from the GitHub repo, you just install and things should work. This one is not easy to set up because you need to first how we set up in the distributed system, we should set up the Arduino framework. Then on top of the OpenVINO, we set up YOLO. That's why you can see like OpenVINO, which is RoboVision OpenVINO packages. Then we have the YOLO, which is this one is I think is YOLO 3. Then OpenFlows, then this interactive base. So these are all the examples that we built on top of OpenVINO framework. But this content is not easy for you to set up. So that's why I just want to show you the example. But if you are interested, you can explore further. So try on it and see what kind of topic available for you to build application. Alright, so can you please run Vim3 and see how it looks like? Okay, so please try this. This is how you only look one. How you only look one. Right. And they use the standard so-called model from the client. It can recognize about 80 types of objects. So you can cross copy this to see what information you can get from this number. And basically it's the same concept. You just subtract the copy, then you will use it. You only can use it. This is if your computer is faster than mine. This has any possibility. So you use it. And when you use the same, but then if I run mine, I think I get about 1 or 2. Yeah, so if you have better computer, you plug in the iPhone, you will better. Like the ones with the robot version. Should be able to do it. So it's possible to like we design and we develop this based on only on CPU. So iPhone can run on because not every machine got GPU. So at least we have something that you go. Because the law use different please try out these 3 examples. I just want to show you the possibility of what sort of application you can build on this example.
So if you try to echo out the topic, you can actually see, for example, the open will actually give you all the value of all the joint. So from this value, you can actually, for example, what application you can find, like for example, you want to find if someone is putting up a pen. For example, then you can find this value compared with this value, it's higher than this person is putting. So you can use like gesture recognition. Yeah, so for so that yeah, you can try to bring out for the topic to see what kind of value you can bring.
Everything okay? Last, so from YOLO, you realize that from the even from the normal Coco that model, you can really recognize a lot of things. I think the most stable is the person. You can recognize person, right? Then you can try like table, chairs, keyboard, telephone, and all those things. Right. So that is an example, and then you can really like, replace the model, and then you can stack, customize object and so on. And then for the open post, you can find one topic that gives you the value of the joint. So from that value of the joints, you can actually design a lot of things that require, for example, gesture recognition. For example, one of the tasks in atHome is like you need to build a waiter robot or waitress robot, right, in restaurant. So normally, like when you want to call the waiter or waitress, you put up your hand, right, to do something like this. So you can use that example to track if this joint is higher than your eye, and that means you are putting up the hand, etc. And also, we have some tasks that require to see the direction of the pointing. That object, this object, etc. Please go there, please go that side. That is or you can give some instruction in pointing, right? So how the robot can understand which object you pointed to, or which direction you are actually pointed. Right, so you can use this as one of the example to show the joint angle or the joint value. And from there you can basically get the vector to see roughly which object you pointed to, right? So these are all the examples that you can use it for a lot of cases in atHome development. Then lastly, also we have this interactive face facial recognition. This one is quite interesting. Usually we will use this to interact with the guests and so on, and it got quite a lot of real application. For example, the gender can basically let your robot understand the guests that he or she, like the guests that you need to entertain. For example, like in a shopping mall or in retail, you want to recommend some product. So you want to like recommend a female use product or male female product by using just look at the appearance and also the age, right? You can roughly know it's a young person or an older person or small kids. Then from there you can give better recommendation and better services. And also lastly you have the facial. So when you for example like you have a conversation, you engage with someone, then after a certain time you figure out like that person not really happy, then you can cheer up by changing the way how you talk to that person and so on. And these are all the things that you can make your robot very intelligent, that you can act more like a human. Okay, so these are all the functions that you can use to enhance the intelligence of a robot when you're doing human-robot interaction. Okay, right. So I'm showing this so that you know the potential that our system can do. So I hope like with this exposure, you can actually have a lot more ideas. Eventually, what else you can actually integrate to build a better service outcome. Okay, up to this point, do you have any things you want to ask? Because I'm going to end the vision part and we are going to move to the next one. But of course, we've got the last step for the vision, which is I want to show you something that uses the distance sensor, the depth sensor, right? Because up to now, we are using the color. So the next one, we are going to do the follow me example, which is the follower. So the algorithm is to use the point cloud, the text cloud that you saw just now. We are going to use that to try to track a person in front. Okay, and with that, I'm going to show you how to combine the I/O that you have, which is the sensor, with the mobile base, so that we can do the follower. And once this thing is, we are going to move to the last chapter, which is the SLAM and automotive navigation, because you need to set up your sensors with the mobile base. Right. So, any more questions about the vision? Any more?
No? Okay, so let's move to the next part. So before I stop the vision part, we can continue the last one, which is okay. So the last for the vision section is I'm going to show you one example that uses the gas sensor. Right. So this is a people tracking system. We always omit the following example. Okay. The following example means so this is a data box, we have the inner sensor. Okay. Right. So we actually get how to say point cloud. Because that's how we see that if someone is blocking in front of the camera, you can actually see a lot of dots here, right? Okay, so we use this information to track the person in front. Okay, the movement of the person in front. So how we do it? Okay, so this is the algorithm. So the algorithm is very simple. The vehicle control, which is the robot control, we use the point cloud to calculate the centroid of in lateral and also in longitudinal direction. Okay, so how we do it? We try to imagine it. So for example, like this is for example, like we have the sensor, this is the sensor, right? And this sensor will be put over here. Okay, so you try to imagine this is a robot, alright? And then in front of this robot, we how to say, we define a virtual box, okay? Virtual box. So that's why you can see we have the X, Y, and Z, right? And follow the convention, the X is this one, lateral. So this is the robot, okay? This is the robot facing this side. X is this axis, right? Y is this axis. Z is this axis. Okay. So we define the X, Y, and Z maximum and minimum so that we define one virtual box in front. Imagine, can you imagine? There's a virtual box. So this is looking from the top. So this is the sensor, which is the robot. So there's a box here. Right, and this is the sensing range, right? There's a virtual box here. So you try to imagine like in front here, when I stand in front, when the sensor is shooting the laser beam, not infrared beam actually. So I have a lot of dots here, right? Okay, so which means something exists in front of the robots. If I do like this, if I'm out of the box, then there is no point inside here. Okay, within this box. So this is like the sensing region that we define. So this box. So depends on this box, we put in the control algorithm, which is first we find the centroid in x-axis. Centroid means when I'm standing in front, within this box, there's a lot of x, there's a lot of dot with x and z value, right? In fact, it's x, x, y, z value. So we take all this x value and find the middle, the average, which is the centroid. Then also we get all the z value and find the centroid. So that is the z centroid in the longitudinal direction. So we got roughly this piece of object, the centroid of this thing. So we assume this centroid is the centroid of this person. So when we move, we can compare with the robot position to see. So the objective of the robot is we want to control this thing. We want to control. We control the rotation of this robot so that the X is always at the center, facing the robot. Then for the distance, we want the robot to keep, for example, a 1 meter distance from the net. So if I'm further from that, right? So which means I'm almost outside of this box. So we can detect like the current distance is actually longer than the X goal. The Z goal. Alright, so over here we use a simple P control, which is we set a gain. Alright, we set a gain. So in your X, if your X is actually whether this side or this side, you get the error, you times, and then you move the robot accordingly, whether it's positive or negative. Right? And then for this one, you times for X scale.
So with this simple P control, the robot will start to move and follow the person. Understand the algorithm? So this one is this is one of the examples to show you how we use the depth sensor point cloud to actually do some application. Of course, you can use this for other applications. For example, another application we can do is we use this point cloud to detect if the door open or close. For example, like because at home we always have one start sequence. The robot will be standing in front of the door. So the start sequence is when someone opens the door, then the robot will start to the operation. So we need to detect the opening of the door. So we can use the same this kind of technology as well. Question? Okay, if no question, then yeah, I need to pass. So can some volunteers to take the robot like yesterday? Yeah, check. Not only have three, there is one. Yeah, this one is my robot. There is one. Okay, so first thing is I'm going to show you how to do this. Okay. So first you need to that can power. So there's a switch over here. Okay, sit down so that everyone can see, right? Sit down. Okay, so once we define the switch, right? Notice that okay, so please turn on the switch to see if it can be powered. Okay, if you can hear the charm, then it's good sign. That means your robot healthy and working. And then you can realize after you turn on, there is a light over here. Yellow color light means the battery is good. Okay, all of them. Green is good. This one? Green. Okay. So green color means the battery is normal. Yellow color means the battery is low. Okay, if the battery is low, please use the charger. I have one charger. Also, it's always yellow. But can charge? No, right? I mean, like the people have to use another battery now. Right. So please keep in mind that the battery might die later on if you do a lot of like things. So you always have your charger ready. Okay. And this is one of the indications. If the battery low, then you will okay. So please look at the battery, and it takes time to charge. So you don't want like suddenly you have to shut down everything then charge. So always charge when you can. Right. So this is the first thing. So after you check, you plug in, and then this is working, it's fine. So you can off the base. So the next thing I want you to do is take your this I/O, put it somewhere in the middle here. Yeah, and then you're supposed to put your laptop in front on top. Okay, but that one they give yeah, and your sensor should be facing in front. The one with the okay. Right. Ideally, supposed to use some method to fix that I/O on that because you don't want it to move. Right. So if you can find a not very like strong double-sided tape, you can take it. This is the front part. Okay. And try to adjust the sensor so that it looks perpendicular to. Yes, the light is behind. It's in front. Okay. This control panel is behind. This is in front. The next is behind. One. So, it's what is equal to like 3 or so once you position correctly, okay. So now this cable over this one. So this symbol, see this is USB to USB to USB, right? You know what USB is. So this one, you're supposed to plug here. Here. This is the communication from your computer to the computer. Right, so you need to find this cable, the square one, into the computer. And this one, go to your PC. I can just see it. Right. Okay. Later, if you want some tapes or whatever, make sure that you secure the cable so that you don't get a tangle. You also want to secure your laptop. Okay, or else that you move too fast and your laptop fly off, it's not my problem, okay? Okay, so you need to take the risk. Okay? So it is your responsibility to secure your laptop. Okay, it's not my responsibility. Okay. Let's go. No. So make sure your laptop is sliding out. Yeah.
This one, right? Oh, so it's just this. Because now it's timing. Just put them in the window. Okay, it's open. Yeah. You want this? You want to show this? Yeah. It's okay. You want for but there's nothing we can change.
Please. Distribution, terminal, and don't
So this time, yeah, it's much.
So, put your robot.
The shit. Yeah, first of all,
Yeah, I know. Okay, so it's very fun. Okay, so you guys gonna jump. Right. So if you have to run the bring up minimal, if you can hear the chunk, that is correct. That is working. Right. Is it okay? You have done. If you run this, the robot is going to start to move, okay? So make sure you stand in front of the robot and it should follow you.
Okay, but mine there's some problem that you never resolved. I don't know why, but okay, you might want to find a space which is more like spacious. You could try this example.
I know only forward the
Yeah. Yeah, but somehow I don't know how to end up something.
Do you need me to help you? Actually, I'm just finding a middle point where I can see everyone without. Because of it. Yeah, leave one. Just shoot.
Okay.
Need to access here.我还没有用，这里要我对不错，对不起。Yeah. Is this okay? What do you think? It's a bit smaller. I think it's good. But then later when people work out, let me try to move it. No, I think just now is you we don't. Woohoo! Okay.
You want? Yeah.
What's this?
Yeah. Yeah, right now.
A bit better, right?
I think you can show the confidence.
Yeah. Yeah. This I can maintain. This one can use until the afternoon session. Because after that you'll just place here playing around. Yeah. So yeah, it's good. It follows a table already, I think. I think it's following a table. Yeah. Just detecting the. change this one. Yeah, you just change it. You have to learn like that's really cool. This because you have to go back and pull some people see what problem and try to make it up. It's okay, maybe this is things. Who does one? You can just delete or add. Snake in your then you change out. You also want
没有咱就是新港湾上面那两层样式的，你看懂吗？但是我是跟你举的给，然后呢，我还得对，我还得
you just step out. You can go back to normal. What? Okay, yeah. It's up. Okay.
合体文化力量其实跟党人完全是对啊，反过来他们就是为了让自己时间会完和There are several parameters. Configure this value. Okay, you can change the size of the ball, change the size of the distance, and so on. By running this, so after you run this, you will have a slider. G1 with the slider you can change. Okay, this one is to change the the detection. Okay, the current default detection, the current the default setting got several problems. For example, if you go through narrow passage, you might not be able to because the box is too wide, so you actually detect the wall. So you actually cannot pass through narrow passage. So you want to your X, the box becomes smaller. But if you make too small, the problem is it can miss the person EDU. So there's no best setting. It depends on the situation. So you can play around with this, the behavior change after you change the parameter. Okay, so this is something that you can try out. You can also change the distance, how far it keeps from the person and so on. Okay? Right. So please try the change the parameter to see the behavior. But so far, I feel the default setting is the best. You just need to restart, then it will go back to the default. Yes. Yeah, please try out.
Just
所以为什么我会喜欢什么？有的话，把一个歪的程度就可以抓到这个。没有，不是，这片已经在这片是总结，下面的应该是哪一片？这片是下面哪一块？这片就是下面。不要关心，关心他。你调的人是比给他先少啊，都行了。我被打不了。
If you want to know, you can research the world check from the Twitter website. You can actually find the follower.ct. I cannot remember this. Yes, we want to我比较小心啊，我给你打个掉下去了。Control C, Control C, Control C。Okay, I think it's enough for you to play with the follower. Let's proceed to the next one, okay? Okay, so can everyone please sit down. Okay, please take a place. Please take a Right, so can we continue? So please take a seat. So after you so later on you can no more, okay? You have technical point of view. Okay, so just want to say like for visual perception, actually a lot of things can be done. And I will show you There are many examples that you can think of. So once you know how to do this, you can actually create a lot of applications, right? Okay. So okay, so I think that's done. So for this one, the assignment is like how far? How to move the head so that then after that you can right. Because more applications that you can think of. But I think to proceed to the source. With 12 months, I only have 1 more hour. 120. Yeah. Show you back.
Hydraulic pneumatic system.
So on the efficiency science as well.
It's too cost. We need test for electronic system. Okay. Anyways, you need to.
What? First one. So use a line. Stop everything not moving. Okay? No, I'm pretty sure the robot not moving. Pretty sure the robot not moving. So we are going to start on this section. See? We can actually have something like a straight laser scan. So we are going to use this laser scan to detect object, to calculate the distance, and then we go around.
You just get this.
But this RGB, although it's very versatile, the accuracy is not that high. And a lot of noise, very noisy sensor. Okay, so when we use RGB to do the math, you need to be very skillful in order to get a usable map. Okay, because in old days we don't have money to buy the LiDAR, we have to use. We have to survive with that. Okay, but today we have more affordable LiDARs. The LiDAR. So this is the LiDAR. So nowadays we use LiDAR to build a map because LiDAR is much more accurate. The distance is much more further, and it gives you much cleaner scan. So later on, you can use my robot to do a comparison. I will show you 2 ways. One is using the RGB to do the map. Another one is using the LiDAR to do the map. You can compare to this from these 2 sensors. Okay, but from experience, the LiDAR will give you much better quality of it. Okay, but you can try. But it doesn't mean that with the RGB you cannot build usable map. You can, but you need to be slightly more patient. You need to scan the map very slowly and make sure that you scan a few times for each corner. Okay, to get a more accurate reading. Okay, and another point that you need to understand or you need to keep in mind is the height of the sensor. Okay, because we are going to do 2D slab, 2D. So it is going to build a map from the level of the sensor. So for example, if you use RGB, so we are going to build a map from this level. Right? So if you have, like, for example, your computer is lower, it's not going to see. Right? So because it's 2D. So you need to always remember like how high is your sensor, and that is the level that you are going to build the 2D map. Okay, understand? Right? Please know this one I'll show you. Okay. So how to build a map? Right. What we need is first you need your photo key. Then it's either you're using a RGB, Astra, or using a LiDAR. Okay. So over here I'm using Astra as an example for RGB and RGB LiDAR. This is the A1 for as the LiDAR sensor. Then you need the computers. And if, as I said, I put optional for mobile base and also for the sensor is because like this document also show you how to do this thing in simulation. So even though you don't have a robot, you just have your Ubuntu as well, you still can do the robot navigation system. You can explore how to develop it totally using the simulator. Okay, so I'm going to show you how. So we are going to use the Gazebo simulator to do the navigation. Okay, so for navigation, 2 parts.
SLAM map building and autonomous navigation. Autonomous navigation means we are going to use the map to tell the robot where to go. Right. Okay, so I'm going to skip all the theory because we only have 1 hour. I'm not going to explain all this thing. I just want to tell you like, okay, so for mobile robots, we have a lot of different mobility design, but SLAM apply to all of them, right? Okay, and then it depends on your movement model. So need to have this model in order for your simulation to work or your navigation to work, right? Okay, so in order to do the SLAM, first we need to understand what is odometry. Do you know what odometry? Odometry means I calculate my footstep to know how far I can travel. For example, I know 1 step is how many meters. So after I take 3 steps, how far I travel in this direction, you can count. Right. So same apply to wheel robot. How much rotation, or you know the speed, then you know the rotation. How many rotation for X and Y, and then how far you have the robot have moved. You can calculate solely based on the rotation and the wheel size, right? Okay. Do all this calculation, keep track of all these things is what we call odometry. Okay, understand? Okay, so we can use odometry to calculate how far the robot travel over the time. Okay, so this is first. Then, in order to improve the accuracy, odometry alone is not enough. Why? Because for odometry, you have a lot of error. For example, in different situations or different flooring, slip may happen, or friction may happen. So when slip or friction happen, your actual movement and the actual rotation of the wheel, the distance that calculate from the actual rotation might be different. Right. So we need another step of sensor to give you a comparison data. So another step is using the gyroscope or the IMU, initial mass unit. Inertial mass, you know what IMU? Inertial sensor. So it's like your handphone. Why your handphone know how far you have traveled? It's because you have the IMU or gyroscope inside there. You know what is the gyroscope? Okay, so from your gyroscope, what data you can get? Acceleration, right? In maybe in different actions. So from acceleration, what you can get, if you integrate, you get speed. Right? If you integrate speed, what you get distance. Right. So from the gyroscope or from the IMU, you can also get the distance travel. So you combine these two and you apply what we call common filter. I think you heard about common filter somewhere for mobile robot implement, right? So we use common filter, apply, and you put these two data in, and you calculate what we call the odometry combine over here, right? And then, so over here you have this robot post EKS. EKS means extended common filter. Extended common filter. So if you want to know how common filter works, yeah, you can Google it and you can search the thing. But important here for you to understand is the robot need to do navigation. In order for the robot to do navigation, it needs to know how far it travel over the time. And in order to know how far it travel over the time, you use 2 sets of data. One is the odometry, another one from your gyroscope or IMU. Okay, that's all. You don't need to understand the detail. If you want to know, you spend time to read the documentation, right? Okay. Right. So now, how to do what do we call? So the second concept. So first is odometry. The second concept is localization. What is localization? Localization means I know where am I with respect to this environment. For example, I'm now in this room near to the screen because I can see. But if I close your eye and randomly put you somewhere, can you localize yourself within this room? No, you cannot. Because suddenly you lost your sensor. So same like robot. If you didn't give the sensor value, basically your robot don't know where am I. Okay, right? So the localization. Okay, so in order to do localization, first we need to have the map. Okay, but to do the map, we do the map and localization at the same time, and that is what we call SLAM. Simultaneously localization and mapping SLAM. Okay, so how the robot does SLAM is like I start from 0, 0. Okay, I say this is 0, 0. Right? So I scan I do a scan on my sensor, and I can see in front here I got an obstacle, in front there I got obstacle, here got no obstacle, behind got obstacle. And I know what is the distance from me to the obstacle. So I write this information down. 0, 0, here got obstacle, here got obstacle, here obstacle, here no obstacle, here. Okay, then I move one step. And from automatically, I know how far I move, right? From automatically, I know how far I move. Okay, so from this, I move 1 meter here, then I record down my sensor value to it. Then I repeat this process until I scan the whole route. And eventually, what you get? The map. That is the concept. Okay, so that is the concept. Okay, so this is how the robot combine. Like just how you have the part on top right, that is the odometry part, right? Now you combine this. So you can see there's a Kinect sensor here. So Kinect sensor is your RGBD. Okay, it's an RGBD, or you can replace that with your LiDAR. You know that. So the LiDAR will give you this information. You can get this laser scan, right? From this laser scan and from the this is the odometry. You put it here. We use another tool called AMCL, Adaptive Multi-Color Localization, in order to do navigation. So after you have built the map, I have the map. Okay, I have the map, and I can calculate my own automatic. So it is time for me to do navigation. Okay, so how to do navigation? I input my map. Okay, I input the relationship of my sensor to my wheel. Okay, what is your Kinect sensor? How far is your Kinect sensor with respect to the wheel? For example, like if your Kinect sensor is looking like, for example, the TF being the relationship of the different sensor to different parts of the robot. For example, like how far is the motor with respect to the sensor? So for example, if your motor is over here, you mount your sensor here. Okay? Then there's a difference in terms of this, right? For example, like now I'm at this is 0, 0, but your wheel is not at 0, 0. Your wheel is at somewhere negative here and somewhere positive here. Right. So in order for me to go to 1, this one needs to go to how many? So it can count. So this relationship is defined in here. Okay? So if I know this relationship, I got the map and I got the scan, basically I can do localization. Okay, localization, how it works. So now I'm going to explain this thing. So AMCL. AMCL is something like this. Now, for example, I have the map, okay, and I tell the robot you are at this location of the map. Okay? So then the robot will read the map, say, okay, I'm here, and then I check my sensor data and see, okay, yes, in front I've got this, in front I've got this. According to the map, this location. But if I didn't tell the robot where am I with respect to the map, then I can go right. So maybe I give you the map, you are randomly at some point. So I turn on my sensor, I say, okay, at current position, I have some obstacle in 1 meter in front, some obstacle on the left right hand side, but no obstacle on the right hand side, and some obstacle behind. So from this map, I plot all the locations that agree with this center data. So I got a lot of right? Can you imagine? Then I use my odometry, I move one step. Then I check again. Then based on just now on the dot, I check everything again to see if it's agreed. If not agreed, I remove the dot. Then I move again, and eventually I left the only dot that fulfill all the sensor data. Understand what I mean? And this process is the concept of AMQ. It's not easy to explain this actually. You read the Wikipedia, then you like, you don't know what I mean. Right, but that is the concept. If you want to know exactly what is the conception, how we going to explain, feel free to read the next part. So we use this AMCL to help the robot to localize itself. So that's why the robot will always do this calculation and always estimate the position with a certain value. Okay? But we can help the robot by using an initial position. Okay? For example, like I'm in this room, but I don't know where am I. Then suddenly someone from the top there, they say, okay, you are at this corner. Then you can easily localize faster. Because like you can eliminate those outside of this region. Then you can make your guess much more accurate. Right, understand? Okay, so this is the MCM. Right. And in fact, for robots, the navigation package is really doing a very good job. Why? Because like the accuracy that we compare for service robot application, basically for service robot application, we are not talking about 0.0001 accuracy. Why? When I ask someone to stand in front of me, okay, for example, I want to talk to this person, I can talk like this. If I move 0.01, will it give any difference? No different, right? So the accuracy doesn't matter to be like up to 0 point something. As long as maybe 0.1 meter different, I think it's fine. So the accuracy is not talking about industrial grade accuracy. Okay? But for service robot, it's important is like we got this. For example, you want a robot to be standing in front of something. Your instruction is in front of something. Okay? So for example, when talking, this is the we have this what we call the social distance. Right? So here during COVID we have, right? So this social distance is something that humans feel comfortable. Because you don't feel comfortable if I talk with you like this, right? Right. So this is automatically, but when I ask you how far is this, you actually don't know. Actually, depends on the relationship, the distance actually changes. There's actually a lot of research paper on talking about this distance. And then, for robot also, like for example, you want to grab something, you also need to know like what distance you need to stand in order to be able to grab. Because like you want the envelope to be within certain distance. Okay, so for us, important thing is later on when you build the map, you need to know where to get the important waypoint. The waypoint that you want the robot to stop or to take notice. For example, like you ask the robot, for example, that is the room. Okay, so for example, you ask the robot enter the living room, for example. So, for example, this is living room. No matter where I stand, it's fine, right? It's within the living room. You understand? So, how to help the robot with? But if the robot standing somewhere here or somewhere here, it's actually not very good because like it might go to another room, right? Okay? So you later on you will find some waypoint that is comfortable to be stayed in a particular room. For example, that is a living room, this is the bedroom, this part is the kitchen. For example, this part is the kitchen. But sometimes this is the bedroom and this is the kitchen, then if I stand somewhere here, where am I? So it's very hard. But it is very hard for us to have a very clear-cut boundary. Okay, so I actually have colleagues that do this kind of how human perceive or how human determine the space that this belongs to a particular area and so on. But for you don't need to go so deep. Today, you just need to, later on when you do the mapping, you need to pinpoint, find a few key locations so that when you ask the robot to go to a particular area, it knows where to go. Alright? Okay, and there are key points, for example, the entrance, this maybe it's an important waypoint. And then maybe, for example, like if that is a coffee table, for example, then standing in front of here is an important key point and so on. So you need to understand like all these key points. Later on, you are going to take the key point, and so that when your mission, for example, you ask the robot to go to the coffee table, then the robot will know you need to come here. Right? And come here, it doesn't mean that if 0.001 to the left or 0.001 to the right, still correct. Okay, so the accuracy is still okay. But important is you don't like crash into something and so on. Right? So for this usage, we have tested like we built. So this is the Jupyter robot team, the engineer teams. We have built the test environment, and then they measure the whole place and build something exactly like this in Gazebo, 1-to-1 scale. Right. And the experiment that we have done is we try to build a map here, and then we use the map inside here. And we do the navigation, and the navigation actually differs very little. And then we do again. We build the map inside here, and we use the map outside. And it also gives us very acceptable answer. So it means the navigation package actually, I can say, is very accurate for our application. Okay, no matter you work in real life, using real robot and real environment, or you are using the Gazebo simulation. So that's why you can learn both, and then you can start doing your application in weather simulation or real world. And eventually, for example, like you have no time, you want to speed up your work, you do everything in simulation, then you put a real robot and it should do it. Alright. Okay. Okay, so how to build a map? Right, you can refer to this open/G mapping. So we are using the G mapping, and this document also explains to you how to do the SLAM with the robot. Okay, but I've summarized, so basically this is how to do it. Right. So I'm going to explain the whole thing then later on only. Okay. Right. And you need to be careful that up there, when I say SLAM map building, and then I've written there robots means real hardware. It will work. Okay, because if you scroll down, you can see simulation. Can you see? Clam map building simulation. Clam map building robots. So these are two different set of commands if you want to do the same thing, SLAM, in real robot or in simulation. Okay, so this is how you do it. So for real robot, what you need to do is first you pick up, which is you start the machine, start the robots. Then after that, you launch the G mapping. So this is the package to build the map. Then you you launch the RVs. RVs is the visualization terminal or window to show the sensor data. You remember that's how I showed you the 3D mapping? That is RVs. So in map building, we use RVs to display the sensor data, and you can see how the map being built. Okay, so I'll show you. And we need a teleop because you need to drive the robot around in order to get the scan, to scan the environment. And after you have done all the scanning, you need to save the map. Okay, save the map. Username for the IO is Mustar, MUSTAR. Okay. Okay, so this is how you build the map. And then, okay, we can use Gazebo. And because we need the simulation environment, because the simulation environment is it will look like this. So we have like one example that you can run the simulator, you can run the simulation environment. And then with this simulation environment, you can start building the map. And you can see it's very similar. That first, we launch the G mapping. Then we use RVs to see the map. And then we use the kernel box to tally up around, and then we save the map. It's very similar procedure and almost similar. I think the only difference is the G mapping page. Okay, one is from the Gazebo, one is for the real robot. Okay, then with that you can start. Right. So I want you to quickly scan the map, and yeah, maybe we don't have time, but we do the mapping first. Right. So can you do the map? Okay, but I want to explain one more thing. Determine several waypoint at several key locations. This is something that I want to explain. But in order to explain that, I need to show you the next slide. Let me explain the next slide first. So for navigation, okay, I'm going to skip this one first. I just want to, okay, so over here, this one. Right. So over here, we actually need some point. Okay, we actually need some point that we, how to say, that we specify as go on. Okay, just like I say the waypoint, right? So from the map, you are going to indicate certain key point that later on we can tell the robot to go to that particular point. Okay, we call it a waypoint. Waypoint means points that you want the robot to go, right? So in order to get the waypoint, this is the instruction. Click the publish point button and move the cursor to the desired goal location on map. And do not click. So this one you do it on your Alvis terminal, Alvis window. And then you record the first two number XY on the bottom left corner of Alvis window. Right? And then you are going to key in this number to the location which I will explain later after you build it. So now, important thing is after you build the map, you want to take a few key points. Right? Take a few key points. So let's decide what is the key point. Okay, so for example, this is the entrance. Okay, so the entrance, maybe you want the entrance, you want to get the XY of this, and you want to get the XY of this. Right? You want the XY of this too. Right? Okay, then maybe you want the XY value of this corner. 1 corner, 2 corner, 3 corner, 4 corner. And maybe you want the XY of this as well. Alright, and also that corner, that 3 corner. So we can use that method to record down the XY of all these values. And then please write on your paper so that you know like this XY. Later on we are going to say, okay, that part is kitchen, for example. Then when you want the robot to go to kitchen, you give this XY value as the goal position. Which I'm going to show you how to use it later. But when you build the map, you can start collecting this value after you have collected time. Okay? Okay. Okay, let's go back to the page. Okay, so now you need to do your assignment, which is this. So, okay. Good. Oh, yeah. Yeah, so I will fix the iPhone and your Mac on the machine. Okay, you need to fix it so that when you move, it looks like. Okay, that's one thing. And also, if you have Bluetooth keyboard, it will be very useful. Okay, or you can use another laptop to install TeamViewer and connect to the TeamViewer on the iPhone. And TeamViewer, if you know how to use TeamViewer. Or else this is not easy for you to be patched off. We are going to follow the law.
Yeah, that's why.
Yeah,
Is this off the camera? Oh.
yeah.
Let me touch this. Just put it in.
If you want to use TeamViewer, please set up local LAN.
Yeah. No. Actually,
So if you want to use remote desktop, remote desktop, you install TeamViewer. But when you use, make sure you use local LAN.
you connect to IP address, you don't connect to the internet number of user. You will set up in your
Alex. Is this automatic?
No, you are using. So you can catch up.
عايز يكون واقفين معاها بالكلام جنب هذا
This would be perfect for a CV application for chat.
تعالوا اطلع من الباب. ايه عشان تسوي ضغط للباب. لا لا بس يعني. It's not just the big fox stuff, but it can be like what? What's the highlight results? Yes, that's what I think to China. What's the good stuff? That's why I was saying, what's the big? It's like, let me find a more. To go back to the 0-0. Yeah, go back.
How to make the
Yes, that's what is the point of خلهم يطلعون هذا كمان It's fine. It's fine. Actually, we can. It's still possible. They eliminate the cars. And so I could go So, how is the map? Constructed the map. You said the map is missing. Oh, you need to use the Excel. Oh, you can actually check from the file. Right, so make sure you save your map, okay? Easier than one. What goes on with it? Because we don't know it. Yeah, you need a lot of practice. So, everyone, for the lunch, we will go one here. So we'll start at 1 p.m. and I'll see you back at 3 p.m. Okay? So in the meantime, when you have time, make sure you get the map, improve the map, make sure you get a usable map. Because we are going to use the map for navigation after this. Okay? Alright, so make sure you improve your map until something is okay? So we will break. So you want me to? I switch to the. Is it okay to link the camera on the we should charge now. This one, this is for the market. We get this. You can't do it for lunch.
System is training together 3 viewers now.
Yeah, something. Yeah, no.
So we'll just make it like that.
We are starting.
不要管，等下你们出我投资，因为你看啊，然后有个微博，完全是我一个是真的，里面有一些人也因为有国外的啊，我们的国家啊，有一个Where do you going? Oh, I'm going to meet with so we won't be going. Oh, so you won't be going for lunch? 因为我们
Then right now I can bring the ball ahead. I can move. Wow. 你说让这样个国家几万块的上面，
几万？确定？
哎，几万的，还有几万。然后我40多岁，那个这个单看嘛，没办法看。完全是不懂什么水啊，是那个。
不要把这里不要有，这里有 on 的不能。
对，是啊。
iPhone 啊，
你要两啊，
我有，能
对，虽然这有了这技法是非常有的，非常好，
你看一下，我觉得这个是原当这个一段之前，
啊，是吧？那个
阿丁的，你好，
别没有啦，
那这样子嘛，是吧？然后，
你们呢？有些是个
这个多少的这种，知道吗？
你们问啊，
对。
那有点多。好啊，
还有很多，
对啊，我觉得是比那种。
第，OK，到底了，哦，是不？不吧？
我有分析一个，说很多。
你没有看比赛吧？因为我看别人吃过，你要把耳朵的话，然后把人生也覆盖在你，还有在，为什么没有？为什么？你我。
他说是好呀。那你这样，
Why we can't do this? His job. Yes. Let's do it. You won't check. Maybe possible. Sakti belum saya possibility. Yeah, so you wouldn't know that assuming you would want to get banned, you wouldn't know that. Yeah. Ini mana? Tak ada kolektor data. Hay ustedes lo tienen map. So you learn that how to go like is you need to launch your own condition. you should tell what your condition you really use to get in and what. Come on, Hey. Those are Như đâu cũng đây rồi, như này là một lần bài. Được thì rồi sau đó phản thì còn nó biết có cơ nhưng mình cái này họ không có để ông mua đâu Amazon được rồi. Amazon được rồi. Ở đây thì theo bạn nếu con sẽ ăn nhiều cái bao là như là cái gì pha vào mình sai không biết nào qua hai người là cái gì cả rồi chiều cái đi trong nhà thì phải cái chuyện phải mà mình phải đi một cái nếu cái là có cái gì là cái văn bản này của cái là cái đi rồi hậu quả của cái gì trên phải nhiều cái có phải sự hiện hiện nay vừa vừa cái số hai tuần thì nó thuyết đầu How the sun would like Maybe to undergrad is that Instead of become it was why not you have where you were this is and the example
他养猫，
跟马狗，我们不是给给子马，我喜欢马狗。你想说，如果他们那个，我也找你们家那导演啊，我是哎，又后来然后对了，那你把自己的带有点，怎么也，他有点带了，他们发现我看。你把那个手跟台大把那个对这个我他们女的那个啊，给相消费者啊大量是吧？对吧？你看，然后他你这个你看技能没办法，我们那里也是有啊，小红书，然后那个给的，这样。还反反的看高高我来对了，来我
等下的看。
你要听完啊，我的两点方面是解读方面开发这两块这个非常来一个对，你还谈上你不让你推荐什么的，鬼了，他们也可以有的。对，
就参加那个训练的那个参与
我看到都有图了。这个啊，他这个都是原始我一起送到你看大家都讲的这样，他去有的。没有这样的一个一点啊，一点半，为什么？这个认识到，这个方式挺重要。要说这个经验，他说几个钱比较高吗？这就讲我们哦，这样，那晚上有，我那我约过那哦，啥地可以啊？这些可以，有。对，我是年轻人啊，来一次考虑你的分享一起的哦，三位是用啊，对不对？以前是关键是哪里工作？啊，对，然后哦，然后还是有地方说我们给了这个卡，对，这个玩意儿。 有限的就是地方。你做少回答那个那个，对呀，是必须的。这个我觉得刚刚必须。因为说。简单的单说，如果这些那太了解，说这这些太了好，他们会先到哪里？可以在后面。哦。啊，你那个有大啊，记得。又出关了，干嘛呀？所以就在这个过来左边，要把节目一场先可以请假我啊，啊，公司每个月都下，下啊。就是看到那留下有没有多少收到？没有，那我看是那个我得啊，你来也多是这个那个什么规章？因为买的还有很方便，这样子，这样子。那个他们这样对不起啊，我给他是那个，因为这里他把它照了，是，你们是怎么办？你非常好，还那里有一个证券，他知道这个阿布是不是他那个为什么口味啊？这是白人，我看到过，Crash test, are you sure? Okay. That's not crash test, it's just a crash. 会吗？啊？会吗？ 这个差啊，会怎么快？如果这个是你自己按的哦，或者别那个头了啊，那个头你来给我画，对，
两个人在吵，
这就危险。
他这放好自己好，那
那你看有没有这样子？不错，还可以看什么？你在那个也看啊，那当然如果对不对？
好像是用那简单用听有没有在背后？
有，或者是一样的。对。他说
累积一下来。
哦。Then how there's someone in the environment.
所以有点在这种认为说。
没有逃避。So let's say something there, then we map it again. So how to update?
If we have to share one exposed after the series, that's kind of it's not like well. All this is what happened earlier.
Maybe when we scan everything, edges of then particular one, other scan like the base where it's only identified. You might scan. I think take the hours. Aku yang di situ itu dalam tempo. Ya, aku di situ. Awal mana tadi? Ini kayak itu sekali dia. Ini semuanya dengan sebuah. Ini juga对，还有舞蹈，对吧？你是看到这个？那他这方面的是吧？我们建议的话是应该可以吧？就是你从走过来，如果可以从走过来，还有从那个，我跟大家来个走很近，然后就提点这些东西的，你可以就是怎样说，除了走的车。
每次在比如说讲一个教练。我说我非常小，这个不大。那你们学习，这个要是。这个，你看我那个，有没有确认？那对，肯定说，这个容易攻击，我感觉他们哦，那边这个。哦，我的，那个可以是有个，
他这个东西还拿出来。他基本上还会卡那个，那白，我现在 这个要去了，不要再来了。你发现过吧？不能搞这个的，这个这个。哎，暑假啊，你有看到？要他我也在玩这个地方，我来听到，还听他说到，对，天宇啊，我是那个。啊，我是整合好。你是给人家说的，然后学习坚持还是有的现在找非常我的，这个你那个啊，你往上，这样啊，不要稍微，你说可能你的这个我也来一下。我试一下电话。可以是的，这个我是两个，我这个啥意思？你们这条电话，这个你那会儿还会他要改那个会手机给，关于开，现在我一点点来，这个也是 CP 区的 CP 区。有的铁上，现在是这个，你说电手，对，你看，那从我前面那边，之前我们这个工厂，这个工厂，我们第一次那时候我们就把它定了，那个在，对啊，一点，你看我们说，这个也是真的，对，啊，现其他的对。可以，全飘嘛，越飘啊，不飘，哎，你给他干嘛？对，对，对，你在搞机构的晚上啊？没有，你来先说，这个没事。不怕，那在西郊，今天这个如果在我家妈的话，我是不会吃完的，我这个拿老了不想走，你看没？唯一天牛我看，我这张看，这个是天牛我看，他没，我没他。英语我都不知道，而且他几天他妈妈，哇，没有，我选择英语我都不知道差距啊，没有，这个是错的嘞。你又不知道这样，这个菜，跟那这什么的，你干什么也不在这里，你只给配的。在这里聊天，我要明白。你考虑到那个啊，这里看呢，那是有人进来了，对吧？时间我看，哦，我说的这个我没考虑。没有我应该算是我这啥，对啊，没啥的，因为高了，就是在有铁皮，我给你，我也快有没有一个男生，你现在吗？ 这个啊，这样子，也。
本身这一块，然后说的话就是，因为这个是我说的都，我给了这个有3年，
他们还有要3年，我们现在讲的是因为他是美，你知道吗？他是在
哦，就跟着他的很美啊。
他自己在那个上面压直播，一人美。
这样子呀，对不对？
他就是让那个东西跟着我慢慢走，
对，
因为他的家他自己人在慢慢压一下，他那个一个他那边很美。看我，
你们怎样？你们是今天会报给分吧？那2个啊，那好的。那有的是，对，就这个是，我跟他们讲，
原来好，我这个我也这样。现在好，直接回到我的位置上。这样好，OK。这个好，好一个。You want to close the eye? Close the close. Check. 把它放这样。对，yeah. Then the front of I don't know come on. 等一下，你们2个同时是吧？会不会碰到了？我要看，对就。志愿是没有拍到我们的，他一直在我们后面，还没有拍到我们。啊，没有看到他的妹妹我们了。他是的距离问题啊。哦，太近了，是不是？太近不到啊，看不到啊。然后那个他讲，对，行，那个好。我想很多，然后你跑，你未来对他是怎么样？教给他的，这个好像是因为丢了，如果他这个中美是吧？啊，你也给我。
这个在海上的，后面，现在在讲。
我整个有些，不大，他跟我谈，他有几条，也是啊，我跟他玩啊，是那个我就是我很喜欢做，那个潮州的，在潮州，另外一个哦。知道，这个也不是，好是。我现在你就这样一个，哎呀，估计也是底鞋吧，这个特别大，然后我就是原来是找不着，明年呀，这个
怎么？
可是我会传过来的，不是谁的？我那那个，没有，泰国。什么地？就是现在就下面那边啊，两个就两个，这个准备，他是怎么做，这个怎么做？我这在，他做都不知道是谁给的管理吗？
哦，是哦，对哦，那时候就是副本的，这里不是我的。
Hello，我来了。Dedication. You are the match.
你有什么？
啊，有，两个。你们家里出那个 diagram 啊，就出那个地图啊。地图啊，resource 20了。第三个第二个兵的第二个那在这个第二个是，对，不要，这是第二个。你看这多吗？对，就是那时候我跟谁对话？那好。但是你要拿到它在对打，然后等下这一下还可以转。那就这样，然后把它塞过去这里。我所以做过人才然后他将来他那个时候还会第一个啊， 为什么给你这么承认的？你看这群，这个在那边。做什么的？你的派
就是你的那个emotion by voice，我一下，
我也很错。我做换成，你是我没来看吗？
怎样认识我？
你说是我，
没有，我。
你认不能吗？我会，现在啊，对，好，这个我还是，这个是来看看，看看呀。
你是我公子啊？你看还有点更没有感觉，我觉得大约啊，
在这儿，
吉利，
我错了，
三年到现在
哦，
如何到呢？每个肚子里没了。所以人家那个是你会那我会吗？是这样，我是算一次啊，这样是点，我也是，我是开始，我。没搞过来，没有。理解。哎呀，因为我的那个那如果是好玩的，我就是来，你不要看，来，要看下面，有效果。那有分店啊，你知道？这边摸，你那边有边缘，啊。
做原来的，哦，那一会儿你看你这拖都没说完，拖这边说一个39几万了，哦，就我这就做了，对呀，哦。你看你，没有这个啊，还可以去别的吗？啊，有电脑，对的，电脑，哎呀，可以先扶着狗，对，怎么说？不可以啊，是吧？或者是吧？压力大一点啊。就是你这个没办法，我没啥都掉了，那个这边手这边都掉下去，不会打掉了。一般来说，在那里是那个可以。哦，我进去才。哦，就是你要外面的也要。你像这样，很多会很多体育场，一般的大。我也是我不记得了。现在人都玩好，我当时我老爸可以，现在这里按的必须高，不得一个扣，然后就我也很是没打，他得可以啊，然后他也换8块钱，这个话也还这里他俩，这有明显是很独立的。哦，那个，因为我的马上都买十啊，我这边穿过的什么来对对，我比较想出来，给你带啊，我不能带啊，我这带啊，你就买了上来，你是得算，所有的带，不要，你这个位，你好，是你要这个玩好啊，你要这个。你还拿过拿人的过去，那个老板是这个不是，跟这个啊，跟你看，好呀，好，这个这个，这好，这个啊，这样，你放我这条道，要换呀，第三，我这个家。你自己要，你知道吗？当时，不是，你看，对，那个，啊，这是东西，所以说是，也是我们上，你把它出来，对，你都自己看，你自己。 这个被叫不能的，一个偏好，非常重要的一个叫在我汇报啊，不考试，我根据啊，对，这样子啊，我这边都考试嘛，就这样子。对啊，然后为什么是呢？你说对了。啊，不用回来，你知道我没讲的，我回来是在我也说的，但是我所以可能我在想，你说我们可以不用，说我不好，这个没有，这样。然后我就被控制了。你放这个吗？我看你们看。啊，这里。Não, é. Olha, eu fui conhecido. Why can't you tell it's zero one?
It's okay. Alex will handle it. Yeah, yeah, don't worry.
I can do this. So, 我是管我是往跌啊，我刚才左右，他啊，然后第什么啊？这我们七个人看到这个好，等下那边还有。那是没有，你该说跟对，那怎么搞？但是啊，但是可以一点点，上不上我得刷有哦，所以不一样的。我从标准出来呀，no，对，所以现在对。算是真的。你玩看。这个nice。我怎么我给你长大，这是哦，我是谁？哦，我是本来就是。我是多干什么？我是。那个这个是。你为什么从这一步往上往这个往这里？那我这个没事没事呀。那我就是。哎呀，
这个下不算正式。好多光分起来。看到这怎么办？
可以改改。但是想好，所以不要看。会有点想法。这里面这些我是会上我多少做这个上，对，他要跟我做完了来了。下面。我都改了点，你还有电脑有个人有这个问，在那个上面因为他们现在那个是个电脑，这个我们当时希望的两个是差不多的，你这样打，你们自己那边打，你看这个，啊我。因为我的那种电脑非常高。还有这个人，啊，多少时间啊？就因为这个前面，然后没说他你看，不到哎，这个还是会很抓。喂，你好，快点啊！哦，你这个都是你的那个对对对，那个我因为自己在玩，还有啥？其实，两个，对吧？应该也不是问题。那我现在我这个可以，他们也开。你们是用什么？我那个按钮是电脑，我们放 NFC，音效的 NFC，一个电脑的看到完全卖出来啊，对。我现在做那些动作，收给做它，你其他东西都是那个，这话比较少，再加一个 Raspberry Pi， 所以我们就直接用电脑，这个都是电脑的系统。因为我们就直接在电脑上跑 ROS， 然后所有的你要是电脑不能看，比较慢啊。Raspberry Pi 你算能力也用电脑，你不用电脑的话 ，don't move too fast。你换回那个地方。不习惯老是背的。哦，那给电脑手机都支持来。
因为我们这个机器人它是有4个模块，就是我们有那个力，然后这些整个出现，然后这个鱼胶这是鱼胶鱼胶所以它这个举单的性，我们是比我们做家里的机器人这个专业的。我说也要把电子化，这个做也。是吧？因为我好像这个就是大家有时候的一个那个，我会过度的一些热度给热啊，有三个说我说对吧？对，我们自己哎呀，没听见，我就像一个嘛，你那边我说，然后你打到好多位置，他所以也是我这个开一个是啊，结束这个我们这个行动，我们这个我们这个会有实际，你的必须要把那个在网。这个发展不是，因为我们这个要搞如果说不一样，这个一个说是我们也不定知道。来有一点基本上他们讲是这种没有，因为我们不想，不过他们就是要准备，因为我们通过这个，然后我们还有另外一个东西，这个就是他们的什么？我看你们的就是这个是怎么的？这个那个基本上是类似有机器人的那个眼睛，这个加入的就是说说那个它是这样，对对，过了这个重点是每一个人可以开一个自己出现对，所以呢，他们上课时候都要12号也不是开放到他们只要把时间手机里面做得好，时间好，你他会人群有16年去了，跟他说然后你就自己把里面也有那个比如说像现在来测试，这是玩的很快，然后就是拍你的那这个。是这样，所以这个是说可以在就是你的就可以谁人在整些这个啊，也是可能就都对。然后对于这个的话，可能就是说大概有那个人这个温度来，其实这样子的话，他们就比较我们说教起来方便。我是真的很接触的是，你这个我们谁摸都能，我们是这个东西，这个 怎么说呢？我跟副理解，然后业务的发展让我告诉这个我们已经需要而且这跟这个多这个对。这个这个就那个机器人大概上个对10分。因为啥你看的，我知道。
所以现在我昨天叫了他们，我有必要都来看。然后昨天的经验都是那个觉得，比如说。Too slow. Too slow. Too slow. That's not what I'm talking about.
Should we resume our class? Is everyone okay? Not yet. Okay, hurry up. Good. Hurry up. Yes, I understand that. So I need to put all those. Yeah, okay. Okay. Why? Don't think the color is navigation. So before lunch, what we have done is we learned how to build a map, right? So you use the robot with the mobile base, which is what we call the computing, and then connect to your PC. And also you connect to the RGB sensor, right? And then the RGB sensor will provide you the scan, the laser scan. So that is the laser scan for the map building. And the Kobuki actually provide you the now there they got the encoder and everything to provide you the optometry. And also Kobuki itself also got an IView. So it provide you two sets of data to get the photometry. And with the photometry with the map, basically you can start doing localization. Okay, so the next part is you want to do the localization using the map with the given map, right? But before that, I want to explain a little bit about the map. Okay, so you can open up your map. Once you save the map, you can observe that there are two files created, right? So one is something, for example, test one, or depends on what name you put, .pgm. Another one is something .yaml, right? So the PGM, if you double click, it is actually an image file, right? An image file that contains black color, white color, and also gray color. Right, only these three. So it is actually a 2D occupancy map, which is white color represent empty space, which means free space that the robot can move. Black color is represent obstacle, wall or anything, right? Obstacle, which means the robot cannot enter the area, anything with black. And then gray color means unknown. Unknown means the sensor haven't scanned that part, so I'm not sure whether it's white or black. Okay, so because it is an image file,
Basically, you can edit it. You can actually edit it using any graphic editor. For example, the IO that you have inside something called GIMP, GIMP. So GIMP is very similar like Photoshop in Windows environment. So you can use the GIMP to, like, for example, when you open up your map, you can see there are actually sometimes very noisy, or sometimes, for example, like when you scan something, for example, you scan a box, which the box is actually lower than your sensor. Then usually you need to how to say, manually draw draw a square to represent the box and then make it black. So that you add that part into your map. And there are actually a few more, for example, one problem over here. If you have something like this, you can see this is the level of the sensor. And when the sensor can scan this copy table, it can only see the pollen. It cannot see the full surface. So what happened is, this is the map that you produce. But this area is the empty area below. But the robot cannot go across this table. So you need to use your post processing graphic editor to actually draw this, become a big rectangular and make it black. Okay, so there are a lot of things you can do to improve your map. So these are one of them. Okay. You should put a lot of effort to make the map as good as possible because you only do it once. Once you've done this, you can use it for many times. Because I mean, like, at least the layout of this room is not going to change. I mean, like, the wall it will be here staying for forever. Right? So you try to improve your map by doing this. And also, sometimes when you scan, you might realize that there are a lot of small dots. Or maybe someone just passed by, then you have a dot over here, right? And this dot is going to disturb your localization later, or your path planning. So what you can do is you can erase all these dots to make it perfect white. So that the robot knows that this area is safely, it can safely move within this area. Because if you have any dot in between, then the robot will try to move like this. Okay? And this is the behavior that you want the robot to move straight. So try to also erase and make the map cleaner. Okay, but anything that you edit should reflect the actual environment. You don't like simply change the shape so that it don't look like the actual environment. That will actually confuse the robot when doing localization. For example, like you put something that is not exist there. Then when the robot tries to localize, it might don't think that it is actually over there. Because from the map, it's supposed to have something there. But from the sensor, you don't have something there. So sometimes it might confuse and thought like the localization is not correct. Then try to readjust itself and then it start to cost. Right? So you need to always remember all this. Okay, then one more thing that I want to say is you need to pick up the waypoint, but maybe up to this point you haven't done the waypoint, it's okay. So I'll explain about navigation, then we will together do the testing for the waypoint. Okay, so let's look at this navigation. So for the navigation, we are going to do like, I need to explain a little bit about robot motion planning, then only we can start the auto navigation. Since we have a little bit of time, I will try to explain the concept as easy as possible so that you can understand. So, how many of you understand the idea of path planning? Path planning. Path planning means, for example, this room, I want to go to that corner. How to actually calculate out the path until that point? For human, you know, because like automatically you know I should move like this and then I pass by that and then. But in fact, if let's say we have several roads, like we can go from here and then I reach that point, we can go from here and reach that point, right? So which path should we choose? So there are actually ways in computer science to solve this problem. Okay, there's actually ways that we can calculate this path. Okay, so how is the way? Not sure any from computer science here? Anyone? No. Okay. So in computer science, there is actually a very classic problem which is what we call the search problem. Do you know the search problem? Search problem means I have a lot of possibility, and after each possibility you have a lot of possibility, and after each possibility you have a lot of possibility. Okay? Eventually you do something. Okay? I give you one example, chess. You understand how to play chess? So chess, you got a lot of possible road you can take, and then each step it open up another set of possibility for you to go. Alright? So in order to know by the end you want the checkmate, you want that situation. So how to reach the checkmate situation? This is actually a search problem. Okay? And that's why in 1995 when I was taken, so IBM created the big blue and solved the search problem, and then like you can win the, like you won the chess league, right? The chess league. And then recently Google, not really recently, a few years back, Google engineer able to create machine that won over the Go chess, the Go chess in black and white. Okay, so these are all, to me, or we understand it as a search problem. So for robot to move from one point to another point, it is actually can be solved by using this search. We can, model this thing as a search problem. Okay, so how we model this as a search problem? This is how. First, we discretize the whole environment into small steps. Okay, we discretize it into small steps. For example, I'm standing here. You try to imagine this is my area that I want to move. So every time when I want to move, I should move one step. It's either this step, or this step, or diagonally this step. So from this point to the next step, how many options are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 possibility, right? Because all empty space. But if I stand in front of the robot here, for example, or one obstacle here, then how many options are there? 7, right? Right, understand. Okay, so that is how I discretize. So I discretize, for example, now I have a problem like this. This is the wall in between. This is the starting point, this is the ending point. And we discretize to become like this. Okay? So every time when I want to move one step, I got 7 possibility. And the next one I got another, okay, but this one I got less possibility, right? Right. So once I have all these things, I can start my search search algorithm. Okay, what is the search algorithm? So for example, I want to do the search algorithm, I go to the next one. Okay, so have you heard about Tower of Babel? Tower of Babel. You got 3 pillars, and then on the far left, we got 3 sides of this. And these 3 sides of this, you can only put smaller one on top of bigger one. You cannot put bigger one on top of smaller one. Right? So you should move the disk one at a time. And the objective is from this pillar, you are going to move all 3 into this. Okay, right. So how many steps you need to calculate this? Okay. So there's actually an equation. You can solve this by an equation. But what I want to say is, you can actually look this as a search problem because like each is a state, original state, and then this is the final state. And then every time you move on this, it becomes a new state. Okay, so for example, this you got 2, and then after that you got 2, and then after that you got 3, and then 1, and then eventually you reach a new. So this is a search tree, and then you got a node and a link and everything. Right. So this problem, so this thing we can solve using a lot of computer science search theory. For example, like you want to search from the top to bottom, like the depth one or the width one way, search like this, etc. You got a lot of ways. So if you want to know more about this search theory thing, you refer to the computer science class. Right, for this. Okay. So using this way, I try to figure out this way. Okay, and then I need to have my policy. Policy means, for example, like I use A-star. I think you heard about A-star. When you on navigation, you heard about A-star. A-star is an algorithm that path with the shortest cost. Over here is shortest cost. Cost can be distance, can be time, can be fees, for example. Right. So over here, for example, I use the most easy, understandable cost, which is distance. So this one. First step, this one, I do this. What is the distance? Then I put a number here. This one, if I move here, what is the distance? I put a number here. Okay, so this number represents the cost. Right? So each time when I put down all the costs, I know which one is the lowest. Then I go to the lowest cost. Right, for example, this one is the lowest, I come here. Right, then I search again, and put eventually I reach it. Understand? Okay, so the cost and everything. So this is how the general concept of path planning. Okay, but of course we can use different policy, we can use different, and then the search also we can have multiple paths or etc. There's a lot of ways to do this. Okay, but this is just one of the ways so that we understand, oh, this is how path planning done and how we can solve the problem. You got it? So this is what's going to happen later on when we talk about path planning. Right, so you understand about audiometry, you understand about localization, you understand about path planning. So this whole concept, everything we put together, then we can do the verification. Right, okay. So I explained this in a very brief form. So if you want to know more, there are a lot of literature and documentation for you to read about it. And I will skip something, for example, like for the object avoidance. Basically, for us, we just assume that every time we detect an object which is new, which is the object that is not belongs in the map, it's going to redo the path planning. Okay? Okay, so that is how the system works. Okay, so now let's do the navigation. So in order to do navigation, you can go to the link to see the detailed explanation, but I try to put it here. So the process, again, we have this one, robots or simulation, right? And then you also realize that after the autonomous navigation, I have bracket RVs and coding. So what are the difference between RVs and code? RVs mean we can use the mouse to specify the location that I want the robot to move. Then I click on the RVs to tell, okay, this is the map. You remember just now when you do the mapping, you got the RVs and you got the map up there, right? So from that same GUI, I can click on the go point and the robot can start move to that point. I'll show you the demonstration after this. Right, so this way is what we call using the RVs way to do the navigation. Another way called coding. Coding means I'm not going to press anything or pick anything from the GUI, but I'm going to write the goal as an XY coordinate into my source code and I run the source code, then it will go to that. So basically it's the same thing as the RVs, but instead of giving the XY to the system using the GUI, I send the XY using coding. Okay. Right. So I will let you do the simulation part. So this one I will let you do the simulation part. I'll explain the robot parts, okay? The real part. So the real part, I'll start with the RVs way. So first is you need to bring up. So bring up is to start your robot. Then after that, I launch the AMCL. So over AMCL, and this time I need to tell the map that I have created. So you need to link to the correct map. If after you launch this, you bring up the RVs and you look at the map, it's different map, that means this path is not correct. Okay? Right. And also, that's how I did mention that after you save the map, you got two files, right? One is the PGM and one is the AMCL. Alright? Just now I mentioned that the PGM is an image file. The YML is basically a meta file to explain some
meta information about the PGM part. So if you change the name of the map or you move the location, you need to update this information in the AMCL, YAML part. Okay? If you change, right? If you don't change, then it should be fine. Because over here, you are pointing the map to the YAML file instead of the PGM file. Right, so just in case that you change the name of the PGM, then you need to tell the YAML file where is the PGM, or else it's not going to move. Right? Okay, so you launch, you run the AMCL, then you bring up, you can see this step is the same, you bring up the RV so that you can see the map, and then for the red robot, you need to give the initial guess to do the localization, which means you need to tell the robot where is the starting position with respect to the map. Because after I do the map, I can start the robot anywhere. I can start the robot here, I can start the robot in the middle. It doesn't matter, it can work anywhere. Right? So once you put the robot, for example, you put here, then once you load on the RVs, you need to use your mouse to set and tell the robot where is the starting position. Okay, so that's the sequence. So once you set the current position, then you can tell where to go. That is the goal position. Okay, right. So this is how you do the demonstration for using RVs to do the navigation. Okay, this is first way of doing navigation, RV. But this way, usually we only do this for testing, to make sure that our map is correct and everything. And also our waypoint is correct, because you are going to test it with the waypoint and so on. But during the competition, you want everything to be automated. You are not going to give any instruction to the robot to do anything, right? So you need to write your instruction in the coding and send it to the robot. So to do that, you need to refer to that navigation.ui. Okay, so I have written one example for you to do this purpose. Right, and that source code is inside navigation.ui over there in that folder. Okay, so let me show you this. The source code. In the navigation grid, you got this navigation.ui. Okay, so this is the thing. If you have time, you can study the whole thing. But now, I just want you to focus on something over here called location A. Can you see this location A? And this location A, we have AX 1.0, AY 1.0, A theta 1.5708. Okay, so this A location is the goal position. Okay, is the goal position. And the X and Y is the goal position coordinate of the goal in terms of X and Y. So you should update this X and Y value according to the goal, the waypoint XY that you want the robot to go. Okay, so you are going to update this. And what is theta? Theta means the orientation of the robot. Okay, the orientation. When you start building a map, I don't know where you start building a map. When you start building your map, then location is 0, 0. Okay, because we need to refer to the map coordinate system. So that is 0, 0. And the orientation, how you start that orientation is 0. Okay, and then it is, I cannot remember if it's clockwise or anti-clockwise, but it is determined using radian. Okay, radian, and then that's why you got 1.57 blah blah blah. Okay, so that is in radian. So how many degree you convert to radian? That's but I cannot remember as clockwise or anti-clockwise. Later you try. Okay, there you go. But how Ross actually use the orientation is using quaternion. So over here, we have this equation to help you convert this value into quaternion and put it into this, what we call the post. Okay, then it will, the rest, the source code will do all the work for you. Okay, so once you send this with the A, okay, so we will come back here. So the way how you want to run the navigation using source code is still the same. You bring up, you launch the AMCL, you bring up the RVs with the map. Then over here you get the point A, X, Y. You write in the code and then you run the code. Then the robot will start to move from the initial position to the point A. Okay, so this is the whole process. Now I'm going to show you this example, demo, and this demo. Okay, so now let me show you this demo first. So can any one of you, which you think you do a good job in building the map, get ready and help me to do the demo? Anyone? Come on, you need to be confident. Anyone? Anyone? Come, anyone that you think that you will build a good map, bring your robot, come here. Hello. Clear the way, son. Okay, where's the robot? Bring your robot here and show me your map. Let me see if this is okay. Okay. Right, so first, for example, you start from here. I would say you make yours. Right. Everyone, please come forward. And please stand over there. Come forward, come forward. Okay, so first, you do the bring up. Okay, so first you do the bring up. You do the bring up. Yeah, okay. Someone can help you showing the comment. Show a comment to where's your teammate? Hello, where's your teammate?
Never mind, later I need to move a bit. Oh, just make it level. You see?
Yeah, you should. Your teammate don't leave it alone.
Oh. Yeah, you know what this make it to and then this level.
Okay.
This was how it was.
Okay, it's not change that you want to hear, right?
Nice.
Next one is you launch the MCL and you link with the map file. New terminal. Yes.
I think maybe I can shrink a bit. Yeah, but this would be nice. That's really nice.
Okay, make sure you link to the correct map file.
Just go back to me. Stop. Turn that just.
You got those facing arrow. More. So did you change your No.
好像是啊，因为 Avis 然后用 GUI 点在那个上面，然后就跑了，应该是啊。
Oh. Oh. So I need to check. We have met. You didn't check anything about that, right? Right. Okay, continue. Right, so now launch the RV.
We can put a lot of because there's need to see the code to know what's going on. Right? No need to really to this.
View navigation right. Okay, give some time. And yes, okay, so now, okay, so start from here. So everyone can see this is the map that previously created and it looked okay, perfectly, no problem. Right. So now, so let me go here. Because this is a two room, right? Yeah. Okay, it should look like this, right? Is it correct? Correct. Everyone can see?
Yeah.
So the first thing to initial position.
Oh.
So now go to 2D phone activate. Okay, you click this, and then you say currently where's the robot? Over here, right? Somewhere here, right? So you click, and then you pull to show the orientation. This orientation, right? Then you release. Then you can see all the arrows start to move here. Okay, so this arrow is the, you still remember just now I said the AMCL thing? The particle filter. Okay, so the first way to tell where to go using this RV way is you can see there is a 2D navigation goal. Okay, so I click on this. Then, for example, I ask the robot to come here. Okay, click, and then I move. I say, I want you to go there and look over there. Okay, after I release, it will start to move. You try to see the red line, which is the path planning. Okay, right? Where is it? Then you can see that it tries to localize every step. Try to move the robot according to the red line, which is the path planning, and try to move until it reaches that line. And it stops. Isn't it actually? And it actually avoid this you don't like. Yeah, because you can see this. Right, so this is how I do for the RVs. Right, okay, so now, so this is the first demo, right? So now I'm going to repeat this thing but using the coding way. Okay, so to use the coding way, okay, now same thing. Okay, can you please change to the next page? Press down. Yeah. So the coding way is we need to we need to find the XY from location A. Alright, and then we write it in the script. Okay, so location A, how to do it is you click this public point. Once this is you click this, you can see when you move you did you can Y Z. Because your robot is not flying, so Z is fine. It doesn't matter. Important thing is this one. So you put it somewhere here. What is the XY? Can someone please write this down? Minus 4.31, comma minus 1.64. Someone please write down that. Or take a photo. Someone please do that. Okay, take a photo then. Yeah. Yeah, where is that? You right. So once you save this, what I want you to do is you open up this file, navigation.py. Okay, you can shut down all this one. You can shut down all that. Yeah, shut down all that. Close. Close. Okay, stop this. And stop. Yeah, you need to close everything. Just from connecting.
Okay, you open up that file, open up the navigation.ui. Okay, key WS, dot, and then raw, and then navigation. Okay, and then with navigation.ui. Alright, so that's what is the value. This is extent y according to the knowledge.
X is negative 4.21.
Negative 4.31.
Y is negative 1.64.
1.4. Okay, we save this one. Okay, please, you can see the theta is 1.5 something. That one is, we assume this is 0. 1 something should be coming there. I assume, okay, but I'm not sure if real, it's correct or not, we will check later. Okay, so now I've inserted the xy that we see from the map and put in there. Right now, so close this, okay, close this, you repeat the same process just now. First, you run the bring up.
Oh, is it? Go not for it. Never mind. Never mind.
Okay, and second, you run.
I think it's okay. Can't do much.
Okay, good. Repeat. Okay, good.
Instant
Next one. You run the.
Yeah, here's here. Yeah.
Yeah. Okay, and then you do the ending of. Okay, so again, I do the same thing. First step is I inject this one to the infinity. You repeat.
People can do this. Oh, yeah, I didn't know it. I didn't know. I didn't know. I put my hand on it. Right, because
So first thing,
oh.
I count the initial position.
This should be unlock one. Should be. I don't know.
Right. So now I'm ready. Right? Ready over there. This one. So now I need to set the navigation code. So now I open up another terminal.
Be careful.
Right. And then we draw one. Our home navigation navigation.py. Navigation.py, right? Yes, correct. So I run this. Okay, then it asks me to give the initial position. I'll give again. Tell the initial position again. This is the initial position. This is the initial position. And you should start the video. Okay, that's it. It do exactly the same thing as the first step, but it's using the coding method. And you go to the chain interpretation there. And let's see if it's and you can see the 1.5 something is clockwise 90 degrees. And it's solved. Okay, so now basically you can
Trying to go back.
but I think yeah, it's correct. The algorithm of that is after you reach the A, it will come back.
Okay.
So it actually saved the initial position.
Oh.
Yeah, the algorithm is it reached there and then it comes back. Yeah, I also forgot about it. Okay. Try to struggle. You want to make the life harder?
Oh.
Should go back to orientation. Is it nice? Yeah, right. So, you try to imagine, you can save all your waypoint into, for example, just now that point is kitchen. Then another one is bedroom, living room, whatever. Then you just tell robot, please go to kitchen and so then you can incorporate this with whatever that you have learned in vision,
species, whatever. Then you can tell the robot, please go to the kitchen, find me a bottle of water, grab, and of course the grabs you need the arm, but one is outside living. But at least now you have the idea to build a specific robot to give this kind of command. It is something that's possible for you to do. Right? Question.
Yes. Can I force the robot to go in certain pattern?
Force, what do you mean by force?
So now the robot chose to go from that side, right? What if I want to go from?
Yes, you add waypoint. You add a waypoint here, you add a waypoint here, you add a waypoint here, you add a waypoint here. Then you will force it. Okay, another one is you try to give using the RV to give that, but I'm standing here. Yeah, use the RVs, use the including navigation, go to this room. Okay, you see what happened now? You see what happened? If I block the waypoint, very good.
Oh,
You see, it changed the path.
yeah.
Is it smart? Okay, struggle. Go. Where you click for God's sake? There. But anyway,
I don't know like what side of blockage should be there so it can.
okay, so in the navigation package, it got what is it called? It got a variable called inflation size radius or something. Inflation means because we have the model of the robot, so we know how big is the size. But the inflation means it will increase the radius. So that if this is a robot, I have the radius like this. So which means this is the safety area. So this is the size of the robot. So to prevent the collision or whatever, it will measure like this is the how to say the passage size. If your inflation is bigger than this, it will never go through.
So I can identify my inflation.
It's written there inside there.
It's written there.
Yeah, you can modify that, but try not to give it too tight. Well, something like just now might happen. Yeah, that inflation radius is a safety. To make sure that it's got enough, but sometimes when the task require the robot to go through like very narrow passage, you might need to reduce that. Or else the robot will stop at the entrance and say, I cannot pass through. Then it just say, I cannot get the path and stop there. Right, so this is the navigation part. Any questions?
No.
No question? Okay. So the exercise for this, because I cannot give you more exercise because you don't have much time. What's the time now? 4.5, because I need to tell you about the competition as well. All okay. Because I need like about half an hour to tell you about competition. So the next exercise for this, usually in the next slide, I would say, okay, find a few waypoints. And then write the algorithm so that you can use voice to tell the robot, go to the kitchen. So you connect this with SR. Okay, you connect this with SR, then it will send that and the algorithm will come. The kitchen there, you can tell the robot, go to living room. Then from that, it will go to living room. So you need to have the logic and algorithm to make this thing like, yeah, but it's just logic and programming. Basic development tools is already there for you to use. Question, no more? Okay, so I want you to try. Okay, so I give you about 30 minutes. Please try with it. This one should look fun, right? Try this. Do it now. Because that's what I did there. After you do it, then you will like understand it better. Okay, try with your robot.
Oh, yeah. Then break it off. Nice.
I just want to. I just want to shoot.
Yeah. But you can use the solid one is a single fact. So here's where nice.
So we don't need to shoot this.
I think now they show. Wait, like, let's see.
Alright.
你的锅盖 robot 这样子是可以做了哦，是吧？有 open day 的时候可以用了，
有啊，没有想到它
所以就可以做了。
调，
对哦，只要有那个 map 就可以了。
调。没有在那个口吧？
哦，OK，这样。
会你们要翻啊？什么嘛？
好什么不一样？还招啊，弄坏也会好啊，招啊。没有，因为我很生气。可能可以啦，我一个人做还没有我煮哦。然后讲我，哎，你就是有那种人哦，没有煮出我进来。所以呢，我们看，啊，那我们后面是。哦，反正我觉得能够。你用它吗？
在我家啊。
你想想。
I think they are memory. Still mapping? GG.
just like this.
Nothing will change.
用可能里面保证人反正那个好像不是啊，那个去吧，跟我介绍，你看这个一种，这个就不用往那管，那个要划，就管这而且那个位置，反正他帮我这样的，因为他两三个人都去。没有那么多人，你看昨天还没有人过来，昨天有天是吧？就是说，一放弃以后，我不要别的放，但是天猫我们就放。这玩意儿就是我懂，这个玩意儿还有个三年哇塞，这是人家这个结婚多少？我妈妈就拿水，我想。大概知道。
Trying to look like what do you yeah, it's kind of better. Or else it will be disturbed. Yes, definitely, yeah. Definitely it's better to fix.
Wow. 就是走，怎么刚好他是这样。
You want to show the audience it's good to you?
Sign up.
Do you like it?
Okay.
The one. You guys have the one.
Stop explaining, man.
Yes.
You can start.你要你看看来他的退去，比如说去，如果你老师会上让他回来。没有，你看我他的方式怎么样？只是他会只是给你一个去拿下，他不会来啊，我们没有办法去管理他。
I think that's what we want to do.
So try test two.
这里音乐给你，
哎，
他会自己把原东西打。
你光你，比如说你就问题可能问题发射，然后来。
Yeah, matter that one. Matter that you want to use the
我是相信你。如果你啊，可以。
这样我这也是一个，这是一个电一个声音，一个声音，一个声音，一个声音，什么的，好，也就最要传给这个人，我也是那在哪里面，这个问题包括还是只有知道这样中间开始。那你这些中职的练习生来搞哪里面？但是我也不太因为如果你是因为你知道，你是那种病，你这一般时间不是去做啊，你讲。也我操他！因为这话是你刚才教我的，其实不懂。因为我马只要是练超过最终的落后，所以我们把一个例子跟例子，我帮他们学一些古德字跟美语。为啥？没有你听就管他们是超群，然后有兴趣的话，对呀。有这个两个字，并且讲它，这八所以那个是，我最终到来西北到我们这往哪来了？那是有分别来的是你们看的我们走，我们他们那个哦。列过，也没有历史历史目的，好，把给没有水啊，有，然后这样，好，是的，然后行，先好，好一点。你说这个不是东西，你说可能有一点，毕竟那没整够。该再有，这是其实就是你觉得反正还我感觉就是觉得我自己不管看看。我很多的大厂有些是非常专业的，老副的任务分析一样，后面必须查一个是他的产品。我花谁说花？我基本上你的特，其实我现在用其实就是领悟面查。哎，我是学霸，然后开始说这个。Go to the next session. 是okay? Okay, all right. 对，所以这个招东西呢，我们就是现在尝试跟学校对接，看看可不可以
所以我们的团队在家庭团队他们是不是进入学院用的？
可是我们不能靠着不错的一个料，然后你是会实力就是像这样接，所以说
相关的时候，我在你的床上，对，在，他们这个在
而且说因为正常接到这边的所以也要必须为例。
我相信看得很好，然后我们就是音乐团体，比赛后面，然后手机可以给我们留在然后就直接是我发
我觉得我看这边，你先跟我们最开始然后你也刚好我妈是那个还有对做实验
一样的，但是在这边专业一样的，只不过就是没有这些历史的话，对对对，没贡献啊，没做，对，我肯定是说。对对，所以这个人真的感觉对，就是一开始就是告诉我来这个，你要没看到就是把这个拿起来，然后开始往上，我听不到，哦，谁是自己做的？所以如果不点进去的话，没办法看看那边过去。所以把这个系统或者这个所有的的很早的地方，在我外对你那个这个你发这些的太多是但是我是其实就是比较有问题啊。就是我们我是少是这个那个是因为这个我是类型，因为不是那个对对吧？然后这个我是哦。还有啊，是。是。然后你发现是。好。您还好。上面上面。Really? It's your movie? What's my name? What's my name? 大家应该自己出来。You try Alvis? Is it working on Alvis? Yeah, they have been trying to On RV is okay, on Mac is not okay. That means your Mac not very good out here. On RV is also not well. That means your Mac really got problem. So, that means your Mac really got problem. Only understand a Okay. Right. So maybe you want to take a seat. I just want to show you, like, all of you seems to have the map problem, right? Okay, I will show you an alternative. Really? Okay, bring your robot in here. Shut down all your terminals and stuff. Yeah, bring your robot in here. Right, everyone, please come over here. We'll show you a demo. Okay. Okay, really, I want. Anyone got TeamViewer? Okay, yes. Okay, just close all the elements. Yeah, can you bring your laptop here? Yeah, just close it down. I might be okay.
不知道哦，对啊，不要。
Okay, anyone with TeamViewer, please try to connect to this.
Sorry.
Okay, can you connect to this ID? 1061 151 33. 151 33, and it's QMSC4. QMSC4B. Alright, okay, thank you. Okay, so now what I want to show you is I show you if we can build the map with the light up. Can you see the one that is turning down there? Okay. Yeah. Right. So to build the map, so now I run the Jupyter one.
你可以渗透过去，才那边。
So now I'm going to build the map using G mapping, the same G mapping, but I'm using the RP LiDAR. Okay, ROS launch. Jupyter navigation. RP LiDAR G mapping. Dot launch. Okay, so you can see it's actually the same thing we are using G mapping, but the only difference is we use the RP LiDAR instead of the RGB. Okay, there's a the top one, the G mapping demo is the one that you use, right? But we're using the RP LiDAR. So now let me show you the RVs. Nobody's heading inside, right? Okay.
No.
Slow power. Slow.
Oh my god.
This launcher, view, navigation. Okay. Can you see like how big is the range? Okay. Yeah, do you have a mouse? Yeah, bring me a mouse. You see, in one shot, it already cover almost everything. Like, so now one. You see that? Can you see the map? Can you see the line? Is it very light? So this is the different use. Can you see the quality of the map? So try to figure out a way to use the LiDAR. That's how you see how straight is the line? You see, and how fast I can do the scale. Yeah, I'm almost done. You see how nice. You want to compare with yours? With this map, you can do much better, right? So that's why I say, like, when you build map, it's better to do this. So now, for those teams that just now have problem with map, maybe you want to save this map and you can actually use this map. Yeah. You see, it actually covers very nicely the whole thing. And you should use Team Viewer. Can you see how convenient it is rather than do like this? Right. So let me run this in one round.
Actually, that's a brush.
Yeah.
So remind me of the brush. First of all,
Yep.
can get relatively better.
Yeah, but you when you push, the odometry is not going to go very
It's
high.
working.
Yeah. So what I want to suggest is when you build the map with RGBD, you need to move the robot very slow.
Yeah,
Yeah, very slow, then it will give you better results. But anyway, you can't get this. So this is the difference that I experienced. I want to show you this. Prove to you that if you have a LiDAR, it gives you much better result, and you make it away. Yeah. And you should do team viewer like this so that you don't need to change the law. Right? Yeah. Anyone, if you want to save this map, you can just copy out you know? Yeah. Okay, you can continue from here. I think it's almost done, right? Can you continue? Anyone? Yeah, I can save the map. So the way it's made yeah, the safer.
Keep this up. Keep this real. If you can remote
see, recognize spaces, think, recognize motion, and right. Then now step about like you can combine the sensors and the controller with the base, and then you can move around, build the map, and then with the map, you can basically ask the robot to move from point A to point B, automatically do the path planning, and also dynamically avoid any object flow. So these are all the tools and the function that I show you and fully we need to show you how to put them together. Okay, so we always refer back to the public right? If you can put them together, you can actually create a lot of very interesting applications. Right. So up to this point, do you have anything you want to ask before I start explaining like the competition so that you have one opportunity to showcase what you're learning? And I think joining this competition will be a good motivation for you to start off really like thinking how to build a complete solution. Yeah. All right. And also for the international competition that I'm going to how to say, introduce to you, you can actually join online without going to the venue. So it won't cost you a lot to join online. Compared to if you want to, of course, the experience will be very different. Like if I do this workshop face to face on site, or if you look at the YouTube, that will be different, right? Especially you have things that move on. I can let you experience. You try the navigation using the simulator. The enjoyment is different compared to you really drive the robot inside. Right, and see the robot, how the robot avoid obstacles and so on. The whole experience is different. So you are very lucky because you have the movie and you have about 3 to 4 units. You have the sensor, you have the sensor, you even have one LiDAR. Right? So I will show you the design, I show you how this thing is done. Please follow this way to build up your robot. Okay, then you can do a lot of things with that. Right. So next thing is I'm going to explain about the competition. Right. So before I jump into the competition, I have one short note about how to put things together. And also there is one example for you to have a look. Okay. So for application development, you can like put all the things together. And what we have here, I will introduce you the people tracking and also the fun functions. So, as a summary of experience classes, so I show you the normal cross, basic, public subscribe. For the speech interaction, you know the synthetic, you know the recognition. And then visual perception, we have the RGBD sensing. So this is where you can get the data, not only color but also the text data, and also the OpenCV application. I also show you a few examples, if you still remember YOLO, OpenPost, and what else? OpenPost and YOLO, OpenPost, and also the interactive base, right? So those are deep learning example that we built on top of the OpenVideo framework, right? So these are all the things. And the important thing is you also learn that you can actually look at the topic generated out from all these examples, and those topics actually give you very useful data that you can straight away subscribe to this topic and start building your application without changing any of the original example. Then I show you about the RAM and autonomous navigation. This part I will say the ROS navigation package is one of the very powerful and useful packages in ROS that if you are working with mobile robots, this package is very, how to say, the design and the algorithm, everything is actually very professional. So you can use this very professional software to run your robot. That's why the accuracy is very, very amazing. And you can compare this with the simulation. It's almost identical. Right? Okay. But the only thing that I don't have time to explain here is about the arm. Right? But I reckon that you can actually learn the arm from somewhere else. Like you maybe have another arm, and then it comes with, as long as the arm is ROS compatible, then you can easily integrate with the system. Alright? Okay, but even if it's not ROS compatible, we can run with Python and everything. Then to integrate with whatever system that we have here is actually not that difficult. Okay, so I don't want to go through this again. I'm going to skip all it. Yeah, so this is actually the simulation environment. So you are going to, so this is the gazebo. This is your virtual environment. You're going to drive the robot inside there and you will get a match like that. So it's very similar to the one in actual world, right? But only you simulate the sensor, you simulate the motors, the mobile base, and then you drive the robot around, you collect the data from the sensor, and then you build the map. It's very similar. Okay, so yeah, please extend from your robot so that you can do more things. Okay, this is how we put together. So these 5 parts, we put all these things together and become a service robot. Okay, so yeah, just thanks to Jupyter Robot that you can see the demonstration of the robots, you can use it, and also for the I/O, it actually saves a lot of your time to do the setup and everything. I would say without it, I am not possible to do this workshop within 2 days. In fact, I do 2 days is actually very, very fast. Right. Normally this workshop I can talk for like 5 days. And then you can have ample time to do the exercise. Because if you do the exercise one by one, it's, how to say, you can grasp the concept of ROS development much better. But now I hope that at least you already have concept how to develop the ROS project, right? Or robot developers. And also for this one, so this is a very useful tool, I would say. If you finally able to install all the stuff by yourself, then that is good. But this will definitely help a lot of people, right? In terms of like setting everything correctly, and the example that I showed you can find actually in fact a lot more example that you can use. Okay. Okay, so let's okay, so you try this combining real and simulation world. Okay, so these are the resources. I think this workshop materials should be sufficient enough for you to learn for several times. So you should, there are a lot of details I didn't talk in detail. And also like you might want to go through those links, for example, like the GMapping link, the AMCL link, and those are the details, OpenCV documentation. I will put in the link, so I hope you can explore by yourself. Okay, right. Right. So and then I also introduce you the people tracking ecology. Yeah. Just now I didn't explain about this. So for example, like I also have one exercise already I'll give. It's like you can use your voice to command the robot to give command to the robot to start and stop the following sequence. So you can say like robot, please follow me, then the robot runs. And stop, follow me, then it will stop. But because this is written not in public subscribe but in services, so I actually have one way to actually do the control. Okay, and I already put the example in the previous slide. So if you want to know how to do it, refer to the previous slide. Okay, so yeah, I think this is the one. So we have this follower control.py. So inside here, I will develop an example that you can put this into your main code, and then you just add SR so that when your SR tell you that the text is follow me, then you can just turn on and off the follow. Right, so you can refer to it. And I only like the other one, but this one is for the Jupyter or the follower. Okay, but this party board name is something that you can refer to. So I developed this example to show in exhibition and also in international competition that we can actually build a party board that can, for example, like talk to you, answer questions, take photo by speech command, and integrate the follower and move the base and the arm and everything. Right. So this may be one of the examples that you can refer to, and the example is over here. So over here we have the act, and we have the party board, so we have to get the click, this one. So this is basically a full version of the code with multiple publisher and subscriber to control. For example, like when you detect where you're from, then you answer where you're from. When you detect, for example, like can you do some sing and dance, then you can copy. And the follower, just talk about the follower. Yes, follow me, then it will say, okay, I will start follow you, and then it start the control follow. So this is how, and also lastly, I split like take photo. So this is how I send, you can see the publish take photo to one of the object, which is this connect to the take photo sound. So you take photo, right? So I have this example, so if you want to build something like this, you can refer to it. Okay? Right, so, and that's all. Okay, so as an exercise, normally I will ask like, yeah, you can start to integrate several features, for example, the navigation, and then, for example, when the robot detects a person, then it will say, hello, how can I help you? They say, can you go to somewhere and look for someone, then you can move, and then look for someone, then tell some story or tell some information and so on. So we can build like various type of application from here. We can update the party model. Okay. Lastly, the competition. Okay, so for the competition, I'm going to explain a little bit about what is RoboCup at home, the task, and then what is inside the Google's, some reference of the previous task, and then what is open challenge, and also what is the application online, and because the online challenge is something that you may be interested to join in this coming life. Okay, so for this at-home education rules 2023, we actually will test if you are going to join the on-site competition, you need to prepare the 3 tasks, which is task 1, carry my luggage, task 2, find my mates, and task 3, receptionist. So you need to build the application, and the detail of all these 3 is written in the book. So you can go to the link, it's written in the book. Okay, but as a comparison, I will show you some example over here. Okay. Okay, so this is a typical at-home scenario. So in at-home competition, we have something like this. So this is the competition arena. So the competition arena is actually very similar to like our house, the living room. And then you will have something, the item is commonly available in house. Chip, juice, snacks, milk carton, water bottle, all these things. Right. So so this I think is a video, so I can minimize this. So I'll show you the link. So I'll show you one of the examples. For example, this is the actual competition. It looks like this. It's a bit, I'm not sure if you can hear the voice, hear the sound, or you cannot hear it. Okay, leading video. Let me hear it now. Yeah. Okay, there's no way because the HDMI thing. Yeah, anyway, so I'll show how you can put your comments. Okay, so this is one of the examples of the competition. So previously, my student developed this robot. Actually, it's actually developed from a robot. So the idea is there will be a group of people gathering in front of the robots, and you're supposed to guess how many people, how many female, how many male. So this is one of the tasks. Right? So you can see that over here. And the noise is basically the actual noise in the environment. It's noisy like this. Okay. So the robot is actually saying something. It's actually counting, then it will turn off. Yeah, then you'll start to look at the number of people. You can actually the robot say that the robot is actually saying something.
So now it captures a photo. Alright. And you say like, okay, it starts to sleep. But the answer is not correct. The human number is 4, and the female is 1, and the male number is 3. Apparently, after we check, if I'm not mistaken, the robot only can see several people in the window, not the person. So that's why the answer is not really wrong. Yeah, this is probably right. Then after that, the crowd is coming to stand around the robots, and then everyone will start to ask questions. Can you imagine how noisy is it? And you need to do the speech recognition in there, like. I don't think we get this one. Yeah, we got this correct. Yeah, so really this is like part of the one task. So your robot has to be fully automated to do all that. Okay. Right. Another one is person recognition result request. Okay. So you'll be test like just now when you capture, you're supposed to submit the result like this is the operator, for example, this is female and this is male. Okay, you need to recognize this and then take out the volume of this from our result in 2016. We actually take this and we got this. And for this task, we actually got quite a lot of high score. Because you can see, we can make the bounding box of all the faces. We can differentiate whether it's a male or female, and we can also differentiate people who win the operator. Then, okay, carry my luggage. Totally carry my luggage in 2017 again, doing this. There's a link capture. Slowly. Yeah, so we can use a follower to follow the person. Okay, then after that, we'll ask the robot to stop, and then it will pass back. We'll pass back, and the robot is supposed to carry the bag. So we count the location bar table, then the robot is supposed to go to the bar table. Yeah. It recognizes the bar table, and then now it autonomously goes to the bar table. Yeah, this is the actual code here. And that is actually the obstacle. Yeah, so that is how. Okay, reach the bar table. Alright, and then it try to put down the thing. Okay, but anyway, so this is and then for this one, is we try to use the gesture recognition to detect the waving. Okay, so it detect the bar table where is the left or right. So it detect. It see around. It use the depth sensor to actually. Okay, then it say that it's on the left. start to find the customer. So the customer will start to wave. So we have an algorithm to actually detect the waving. So okay, it takes some time to actually go and find the person waving. Okay. So eventually it's okay, yeah, you can see. So it detect the face and it detect the hand. So this is using, I think it's using OpenTV to detect the face and detect the hand. Then when it reach the bar counter, it's supposed to take the order. Right, so you ask like what you want to order. What do you want to order? So you receive the order. Can you hear music, right? So that's how noisy it is. Okay, so you need to go back there, and then, yeah, because our arm is not working, so we actually put the object. So we say put the instant noodle on me, then we put it. Yeah, and then it moves back to the bar table. And for this restaurant part, we are not supposed to give the map. So the robot has to explore the place and find a person without having a map. So that is also the challenge. Restaurant. Okay, so these are all our things. Let me show you other things. Okay, so this is from international team or other teams, which is Team Homer. Team Homer, they got champion in world competition. You cannot see this. Yeah, Team Homer is one of the championship. You can see their restaurant hub. Can you see even more noisy? For at home, you are making this kind of loss.
So try to move to the bar table to collect the orders. So keep in mind that Roma actually don't have the map of this environment. It really need to figure out a way. So we need to move to get application faster. Yes. Very like Here, very much. Yeah, so more really make some issue is one of the example. So the receptionist asked. So the robot supposed to Right. So reduction of plants also by removal. So the robot supposed to, you can say, like open the door, it's supposed to greet the guest, and then get to know a little bit about the guest, and then introduce the person to the living room, and try to sit quiet and so far for the guest to sit. So introduce the person. So you need to actually figure out which sofa is occupied. You ask the person to show where. Offer a seat. They points at particular seat over there. So this is the empty seat. Then the guys. So basically, then after that, you introduce every guys. And then talk to the person. You need to know the name so that you can introduce to the other guys. So you ask the name, then you come and introduce it. Right. And the robot is trying to find a seat. Yeah, over there. That's the implicit. So basically that's how much. Right. Okay. some example of what is the real task in the atHome. So we have several tasks in the competition and you're supposed to do this task and try to solve it during the competition. Right. And also we have open challenge. So for open challenge, usually occur during final is you can showcase your research work. For example, like for service robot, I have one kind of scenario. I want to solve this problem, and I develop a new technology to do that. We are going to present it in open during the final, right? Okay. So because of the time, I'll keep this because I don't think it's easy for you to understand this as well. But you can see like they are trying to explain, they have to create a scenario like just now, and then they are going to explain how the robot solves the problem, and then show you the technology. Alright, okay. So there is open challenge. Right, and we have a lot more videos. Right. So if you have time, you can go, I put down the link for open challenge, online challenge 2020, 21, and 22. Technical award challenge and so on. So open platform, you look at the open website, platform is a platform. Okay, so you look at the open platform, and these are a big collection of references that you can learn from the previous video. Okay, so combine, right? So the final we do the last one is build your survey. Okay, so with that, I complete my workshop for these 2 days. And if you have any question, feel free to ask me. And also before we end, we should have we should take a quick photo. Right? Any question you want to ask? Anything you want to ask? So I asked, yeah, we can take a photo. We can take a photo together. Anything you want to ask? Yeah, join the competition. So if you want to know about competition, please come to this website. Okay? In here. So if you click, then you can see. So this is the competition. And then there is I basically recorded the webinar, which is I explain the whole competition process. When you need to do what you need to submit, how many categories, and so on. So if you have time, you can watch this video to have all the explanation. And I have the slide over here. You can have a look. And then if now you want to join, I think the best timing should be by end of May. You need to submit the team manuals. Okay, for more details, please look at this website. Okay, I look forward to your entry. For online challenge, please you can join very right? Okay, so that's all. And let's take a look. So can you like, yeah, bring your robots and we take a photo together.
Use handphone or what?
Right, if you are online.
Yeah, still on my plan. This is my.
Just
Good.
yeah, so we're not getting why?
Yes, let me talk. Press the press
Okay, is it okay? Everyone come into the camera.
Okay. Can you look in a bit?
This one and this one.
Alright. 1, 2, 3, smile. One more. Okay. Do you want to go first? Last one. Great. 1, 2, 3, smile.
Thank you very much. Oh no, you left. Yeah.
Let's pick up the place.
So we can end the stream already, right?
I think so.
Hey, good countdown. People left. Sweetly and stuff. Make sure that you know do it properly and speak about it. Oh, yeah.